Anupam, good morning. Anupam, good morning. Atrey, good morning.
Good morning, sir.
Good morning, sir.
সাউন্ড আসছে না। হ্যাঁ, এবার আসছে। নাও ইট ইজ অল রাইট। ঠিক আছে না? শোনা যাচ্ছে তো?
Yes, sir. Yes, sir.
হ্যাঁ, ঠিক আছে, ঠিক আছে। অনুপম জয়েন করেছো? না, অনুপম মনে হয় কানেক্ট করে তারপরে অন্য কাজ করছে। ঠিক আছে। Supriyo, good morning. সুপ্রিয় শুনতে পাচ্ছ? গুড মর্নিং। সুপ্রিয়, সুপ্রিয় নেই?
Hello, sir. Am I audible?
Yes. Good morning, Soumi.
Good morning, sir. Good morning, sir. Supriya sir has joined?
Yes. Some sound is coming in the background. I don't know.
Yes, sir. Just
Now it's okay. Now it's okay. But don't reduce too much.
now it's okay, sir. To respected eminent speakers, organizing team, and participants. Welcome to the fourth day of the 5-day online faculty development program on recent trends in civil engineering, organized by Department of Civil Engineering, Haldia Institute of Technology, Haldia. Today our speaker for the first session of the day is Dr. Supriya Roy, Associate Professor, Department of Mechanical Engineering, Haldia Institute of Technology. Doctor Roy's current area of research interest is mainly aimed at the investigation of turbo-corrosion behavior of coated surfaces. Sir is a recipient of research grant from CSIR Government of India. Today, Sir will be discussing on advanced mechanics of solid, or more specifically generalized Hooke's law for deformable structural members. On behalf of entire Civil Engineering Department of Haldia Institute of Technology, I welcome you, sir. We are thankful to you for accepting our request and joining us in this session. Over to you, sir. Okay, due to some network issues, Dr. Supriya Roy would be joining us in few minutes. Sir, Dr. Supriya Roy, sir, you connection
Hi.
issues. Okay, okay, sir. So, uh, due to network issues, since we could not connect to Dr. Supriya Roy, sir, so let us welcome him again on behalf of the entire civil engineering department. Sir, we are really thankful to you for accepting our request and joining us in this session. Today, sir will be discussing on advanced mechanics of solid, or more specifically, generalized Hooke's law for deformable structural members. Over to you, sir.
Supriya,
Thank
good
you.
morning.
Good morning,
Very good
sir.
morning.
Very good morning. Thank you, sir.
Uh,
I first thank you, the Civil Engineering Department, for inviting me for presenting this topic today. So, good morning to all of you. So, without wasting time, I should start now. Uh, I hope you can see the screen right now.
yes, no problem.
Okay.
Perfect.
Okay, so today I'm going to discuss about generalized Hooke's law for deformable structural members. Now, from our school days, we are learning this Hooke's law. That is a very simple law. The stress is proportional to strain up to some limit. That is called the proportionality limit. And it has a very small mathematical expression, that is stress by strain is equal to elastic modulus. Okay. So, though this equation is very small, um,
Excuse me, sir.
yes,
Uh, could you just put the entire screen and the view mode? It is still in the compressed mode. Like we cannot see the whole screen of the PPT.
okay. So, just let me do one thing. Is it visible?
Yes, sir. Yes, sir. It is visible.
Actually, if I make it a full screen, it is making some problem.
Okay.
Okay,
Okay. Continue.
so that's why I'm doing all these things. So it
Please
will be
continue.
from
Supriya, it
my
is all
side also,
right.
it will be better
Please
to
continue.
explain. So if I make it as full screen,
No
so I
problem.
am
Supriya, continue. It's excellent. No problem. Please
okay.
continue. No, continue.
So so let's start it again from the start. So from our school days, we have learned this Hooke's law. That is very simple law. The stress is proportional to the strain up to some limit called proportionality limit. And that mathematical expression which we have learned, that is also very simple one. The stress by strain, that is equal to elastic modulus. Though the equation is very small, but it has huge importance in view of structural mechanics or design of load-bearing structural members. If there is any miscalculation or wrong assumption, a drastic failure of such structural members we can see here. So these failures can be taken place. To avoid this, we need to learn that basic assumptions and what are the basic stress-strain relation. Now, the first during our school days, which we have learned for uniaxial loading, the mathematical expression, the interrelation between stress and strain is given by this simple equation. For longitudinal stress equal to Young's modulus E into longitudinal strain epsilon. But most of the practical situation, the loading, external loading is not uniaxial. Rather, three-dimensional complex stress acts on each and every load-bearing materials. Just like that way, if I take a solid element, we can see here different types of normal loads and normal stresses and shear stresses are acting in different directions. Okay. Now, these stresses will cause some strain, or in other way, if some deformation takes place on that material, some stresses will be generated. So this stress strain behavior depends on the type of the material. It is the material behavior, uh, not the body on which the load is acting. So it is a material behavior. So the behavior of the material, so before going to understanding of the behavior of material, we need to have some brief knowledge about the structure, material structure. So for that, we need some idea of continuum mechanics. So in general, if we look at the microscopic structure of a material in atomic view, we know each and every material consists of some atoms. So if I consider this one is one atom, another atom like that. So these are stacked like that way to form the material structure. With further smaller scale, each atom can consist of some protons and neutrons at the center, that is called the nucleus, and on the other orbit some electrons rotate like that. Now the basic mathematics tells us that in between 2 points we can always find another point irrespective of how close are these 2 points are. That means there is always a gap in between 2 points. So we can say the physical space which the material occupies is not completely filled by those particles, fundamental particles. But the concept of continuum mechanics is ignored to the discrete position of these fundamental points. Rather, we will consider in continuum concept that the material is completely filled, the space, that is a continuous flow occurs through the material. That is the concept of continuum mechanics, and we will consider this concept of continuum in our structural mechanics also. So there are different tools for solving different problems of continuum concept. So one of such tool is tensor algebra or tensor calculus. As we all know, the stress and strain are form of tensors. So a brief idea of tensor. So tensors are a generalization of vectors. A tensor can be described as something which like a vector and can be measured component wise in any Cartesian frame. Now Cartesian tensor, so specifically Cartesian, what is a Cartesian tensor? A Cartesian tensor of order n is an entity that may be represented as a set of 3 to the power n real numbers in every Cartesian coordinate system, where n is importantly a positive integer. Example of tensors are stress tensor and strain tensor. So why this stress and strain are called as tensors, we will be looking in our upcoming slides. So what are the different types of Cartesian tensors are there? So there are several types of Cartesian tensor: zeroth order tensor, first order tensor, second order tensor, third order tensor, and fourth order tensors. So the physical quantity, the example of zeroth order tensor is time, density, like that. So we know all these quantities are scalar quantities. That means it has only magnitude, not any direction. So a single symbol is sufficient enough to describe the total quantity. And the maximum number of elements, as it is a zeroth order tensor, we have in our previous slide we have learned that if it is a nth order tensor, the total number of component is 3 to the power n. With that assumption, we can say this is 3 to the power 0, that is equal to 1 element is necessary to describe it completely. The first order tensor, the example is velocity, acceleration, like that. We know all these quantities are vectors. Now we know that vector not only require magnitude but also direction, such as velocity. In our 3-dimensional coordinate system, we can measure the velocity along x-axis, velocity along y-axis, and velocity along z-axis, like that. So a single subscript is enough to describe a first order tensor, and how much component it will have, as it is a first order tensor, so it is 3 to the power 1, that is equal to 3, minimum maximum 3 components is necessary to complete describe a first order tensor. The second order tensor is stress tensor and strain tensor. So that is called a dyadic. So not only a single direction along with magnitude, not only a single direction is enough to describe the stress, but two directions or two subscripts are very much important to describe it properly. Now, as it is a second order tensor, so it will be 3 to the power 2. So that is 9, maximum 9 components is needed to completely describe a second order tensor. And as we all know that stress and strain have 9 rectangular components. I will describe this portion later on. The third order tensor, a torsion tensor, that is called a triadic. It requires minimum 3 subscripts to describe it completely. So it is a third order tensor, so 3 to the power 3, 27 components are needed. And fourth order tensor is stiffness tensor, that is called tetradic, and minimum 4 subscripts is needed to describe this completely, as it is a fourth order tensor. So 3 to the power 4, that is 81 maximum number of components are needed to describe it clearly. So this was brief about the Cartesian tensor. Now I'm moving to the stress. So as we are going to establish the Hooke's law here for 3-dimensional structural members, so I must start with how many way we can resolve a stress components. The first one, for this we have considered a 3-dimensional object in a 3-dimensional space with a surface which has a perpendicular or normal direction n. So if I see the enlarged view of this 3-dimensional object, we can see, so on that surface, this is the normal direction. On that surface, a stress is acting on that normal plane n. That's why it is denoted as Tn. Now we can resolve this resultant stress into 2 ways. The first way is to resolve the stress along the perpendicular direction and along the parallel direction of the surface. The first way of resolving the stress is to resolve it in the perpendicular direction and the parallel direction of the surface. We know the stress component which is perpendicular to the stress surface is known as normal stress and shear stress. So if I resolve this T into a normal and shear component, we can get the first algebraic equation relating the normal component and shear component with the resultant stress. Now in other way, we can resolve the same stress, resultant stress, into along three mutually perpendicular axes of coordinate system, that is along x-axis, Tx on the n plane, Ty on the n plane, and Tz on the n plane. So these are the three other way. In another way, we can resolve the stress in these 3 components along 3 mutually perpendicular axes. So this is the algebraic equation relating the magnitude of these 3 components to the stress system. Now, how many rectangular stress components are there? So for that, again, we have considered a solid object, and we have taken a plane on that solid object which is parallel to the YZ plane, Okay. Now, on that surface, on that plane can also be called as a x plane, because the x-axis is perpendicular to that of plane. So instead of calling this as a YZ plane, we will call as a x plane. In the similar way, the plane which is perpendicular to the y-axis, we will call the plane as a y plane, and the perpendicular to the z-axis will be called as a z plane. Now on that x plane, a stress vector is acting, or a stress tensor is acting as Tx. Okay, now we can resolve this resultant stress tensor into 3 mutually perpendicular components along x-axis, along y-axis, and along z-axis. So the component, so we must see that all these 3 perpendicular components are lying on the x-plane, are acting on the x-plane. So first we should write this Tx x, tx, x, and txx, suffix x, because all these three stress components are acting on the x plane, but the direction of each of these components are different. So the first subscript indicates the plane on which the stress is acting. Now we need to describe another subscript which will indicate the direction on which the stresses are acting. So you can see this stress is acting along x-axis, so it will be txx. As this stress is acting along y-axis, so it will be txy, and the third one is along z-axis, so it will be txz. So we can write in a matrix form on x plane. On this vertical column, we have written all these plane, x plane, y plane, and z plane. And on these horizontal rows, we have written x-axis along y-axis along z-axis. So on the x plane, we have seen there are three stress components are acting. One is tau xx. We are generally expressing the stress as a tau for right now. So this is tau xx. The first x indicates the plane on which the stress is acting. The second subscript indicates the axis along which the stress is acting. So tau xx, tau xy, and tau xz, these three stresses are acting along x plane, along the three axes. In the similar way, we can say tau yx, tau yy, and tau yz, these three stresses will be acting on the y plane along x-axis, along y-axis, along z-axis. And on the z plane, it will be acting tau zx, tau zy, and tau zz along x-axis, along y-axis, along z-axis. That means to describe a stress component, we need at least two subscripts. The first subscript will indicate the plane on which the stress is acting, and the second subscript will indicate the direction on which the stress is acting. So it has two subscripts, and it has total 9 components. So we can see on this matrix table there are total 9 components. That's why this is a second order tensor. So stress is called a second order tensor. So there are total 9 rectangular stress components there. Similarly, there are 9 corresponding strain components are also there. That's why similarly the stress as like stress tensor, strain matrix is also called a tensor. Now, you know, when these two subscripts are same, when the two subscripts are same, it indicates the stress is acting perpendicular to the surface. So xx, yy, and zz, these three stresses indicates the direction of the stress is perpendicular to the plane on which it is acting. So these three components will be called as normal stress component, and the others are as parallel to the corresponding surface. So other 6 components are shear stress components. So normal stress there are 3 normal stress components and 6 shear stress components. So for any solid element, we can see here a parallelepiped, a solid element. On that solid element, all the distribution of this all rectangular stress components are shown here. So along x-axis, sigma x, tau xy, tau xz, like that. All the stress components are active on that solid element. So that is just for representation. Now, what if the stress is acting on an arbitrary plane? So we have till now we have learned what are the stress rectangular stress components along the reference planes, that is x plane, y plane, and z plane. Now, what if there is any plane arbitrary angle? So for that, on that solid element, we have considered an arbitrary plane of this triangle ABC, like that. So we have taken a plane. So we have separated out the plane along with the coordinate axis x, y, and z. Here we can see this is the normal vector. This is the normal vector of that plane. And this normal vector cuts the plane at point D. Normal vector cuts the plane at point D. Now, the projection of the plane ABC on the YZ plane, the projection of the plane ABC on the YZ plane, that is BPC, that is a triangle, or YZ plane means X plane. So we can say the projection of the plane on the X plane is BPC, the projection of the plane on the Y plane, that is APC, and the projection of the plane ABC on the Z plane is BPA. Now, if this is the normal direction, so we have seen that all the projections are a triangle. So if we consider all the projected planes along with the original plane ABC, it will form a tetrahedron. Now, this P to D length will be the height of the tetrahedron. We can consider this height as h, P to D distance as h. Now, if it is the normal vector on the arbitrary plane ABC, now if the normal vector makes an angle alpha with the x-axis, we can say the direction cosine along x-axis nx equal to cos alpha. If the normal vector makes an angle beta with the y-axis, so we can say the direction cosine along y-axis ny is equal to cos beta. And if it makes an angle gamma with the z-axis, so we can say the direction cosine along z direction nz equal to cos gamma. With such a constraint that nx square plus ny square plus nz square, that is equal to 1. Now, let us consider the area of the arbitrary plane is A. Area of ABC. Area of the plane ABC is equal to A. We are considering the area of the plane, area of ABC, that is equal to A. Now we have seen, let me remove this one. So we have seen the projection on the X plane is a triangle BPC. So the area of BPC, that is the projection along the X plane. So that will be A into NX, the direction cosine along x-axis. So area of BPC is A into NX. Similarly, area of CPA, that is area of this triangle, the bottom triangle, that is the projection along y-axis. So we need to multiply the area with the direction cosine along y-axis, that is A into NY. And the area of the APB is the Z plane, that is this triangle. The area of this triangle will be the projection along z-axis, so A into nz, the direction cosine of the nz. So why we have calculated the area? Because in the next slide we will be applying this area to find out the force on each and every plane. Because if we multiply the area with the stress, we can get the total force. So for this purpose, we have taken this elemental portion, elemental tetrahedron here. You can see on this 3 reference plane along x-axis, you can see 3 rectangular stress components sigma x and 2 shear stresses are acting. On the plane y, sigma y and 2 shear stresses are acting, and along z-axis or z plane, sigma z and 2 shear stresses are acting. And on that arbitrary plane ABC, 3 rectangular stress components Tx, Ty and Tz, these 3 are acting. Now our aim is to find out the expression of this Tx, Ty and Tz with reference to these rectangular stress components sigma x, tau xy, tau xz, all these things, all these rectangular stress components. So for that, what we will do, we will write the equilibrium equation along x direction. That means we will be equating the force which are acting along x axis. So for that, first find out the stresses which are acting along x axis. So this is the first stress which is acting along x axis, Tx, and on the arbitrary plane. The second one is sigma x, that is also acting on the x axis but in opposite direction. Here you can see a shear stress which is acting along x axis. So this will be tau on which plane? On y plane. On which direction? On x direction. So this will be tau yx. And this is another shear stress which is also acting on the x direction. So this is on which plane? This is on z plane. So this is tau z. And in which direction? X direction. So this will be tau zx. Now we need to multiply these stresses with the corresponding area on which it is acting to find out the force equilibrium equation. So this Tx is acting on the arbitrary plane and the area of the arbitrary plane is A, so the force is Tx into A. That is in the positive x direction. The sigma x, which is acting on the last one is the body force component. The last one is the body force component. We can see here. Now, if the body force is gamma, so we can write this gamma as gamma xi plus gamma yj plus gamma zk. So this gamma x, gamma y, and gamma z are the three body force component. And body force is a force that is per unit volume. As we have considered in our previous slide, the height of the tetrahedron is h, and we have considered the area of the arbitrary plane is A. That means the area of the bottom area is A. So the volume of this tetrahedron will be 1/3 A into h, 1/3 the area of the base into height. Okay, so this we have considered here. So now this is the equilibrium equation along x-axis. Now if I cancel A from this equation, we can find out the first rectangular stress component along x-axis on that arbitrary plane in terms of sigma, tau, and all these rectangular stress components. Similarly, finding the equilibrium equation in y and z direction, we can find other two components also. Now if we ignore the body force component, because this force is very much negligible compared to the external loading, so the three stress components on the arbitrary plane can be written by this equation, and this equation is known as Cauchy's stress formula. So Cauchy's stress formula can also be written in matrix form like that. Here we can also see the 9 rectangular stress components are there. Okay. Now from the strength of material of view, from these 9 rectangular stress component, we can say this shear stress will be equal to this shear stress. This shear stress will be equal to this shear stress. We can prove it from the elementary strength of material, and this shear stress will be equal to this shear stress. That means we can say the stress tensor or stress matrix is a symmetric matrix, and all the 9 components are not independent, rather only 6 components are independent. So these normal 3 stresses and 3 shear stresses. So the 6 independent stress components are these, and the shear stresses which are equal to each other are known as cross shears. So we can say not the 9 components are independent, rectangular components are independent, only 6 rectangular components are independent each other. So this was basic about the stress. Now we will move towards the relation, establishing a relation using Hooke's law in between stress and strain. So as we know, Hooke's law is applicable for only proportional limit, or we may call it an elastic limit to some cases. So what is the elastic behavior? So elastic behavior can be characterized by 2 conditions. One is there will be a unique function of stress and strain. Okay, the mathematical expression will be a unique function of stress and strain. And the second one is the material recovery property. The material has the property for complete recovery to the natural shape upon removal of the applied force. This is the condition for elastic behavior. Okay. Now, elasticity may be a linear elasticity or non-linear elasticity. If after loading, the stress and stress relation follows a straight line, the curve follows a straight line, and upon removal of the load, it will regain its original shape. That is called the linear elasticity. Linear elasticity. if the stress strain relation is not a straight line, rather a curvilinear. Okay, but after removing the load, it will regain its original shape. So that means it is elastic, but it is not linear. So this is non-linear elasticity. Non-linear elasticity. And if there is any permanent deformation, we all know that is the plastic deformation. However, our discussion will be confined on this linear elasticity. That means the Hooke's law within the proportional limit. Now the relationship between the stress and strain components will be established here, and such equation will be known as constitutive equations of these stress components and strain components, or rather stress tensor and strain tensor. Now from the elementary strength of material, we know that the axial stress is proportional to the axial strain up to a limit called the proportionality limit, and we all know that the very important equation, famous equation, that is sigma is equal to E into epsilon. Linear stress is equal to Young's modulus into linear strain. Now this is for uniaxial loading. Now we will extend the information of knowledge to the 6 rectangular component of stress to the 6 rectangular component of strain. Okay, now we will assume that this is much more important line here. We will assume that each of these 6 independent component of stress may be expressed as a linear function of 6 component of strain, and vice versa, because we are dealing with linear elasticity. So it must be a linear function of stress and strain. So each stress component can be written as a function, linear function of 6 strain components. So this is the expression of each independent stress components. As I told, as we have discussed in our last slide, that there are 6 independent stress components are here. So these are the 6 independent stress components, and each of these stress component can be represented as a linear function of all these strain components, like this. If I rewrite this equation in matrix form, we can get this matrix here. This C is establishing a relation between stress and strain. We can call it elastic modulus. Or this total matrix, 6 by 6 matrix, is called the stiffness matrix or matrix of elastic modulus. Now you can see, to describe each of these elastic constants, we need 4 subscripts. So why 4 subscripts? The first 2 subscripts comes from the stress component, and the last 2 subscripts come from the strain component, establishing a relation. So first 2 comes from the stress component, and the second 2 comes from the corresponding strain component, like that way. Like that way. It goes on like that way. Okay. So we have seen, to describe each and every element of the stiffness matrix, we need 4 subscripts. As I told you in our initial slides, that a 4th order tensor require at least 4 subscripts. So we can call it is a 4th order tensor. The stiffness matrix, we can call the stiffness matrix as a 4th order tensor, because we need at least 4 subscripts to describe the whole matrix. But we know a 4th order tensor must have 81 maximum components, but here only 36 components are there. Why it is such? Because the stress matrix generally corresponds 9 elements, but out of these 9 elements, only 6 elements are independent. Only 6 elements are independent. So we have eliminated the remaining 3 stress components. If there were 9 independent stress components and 9 independent corresponding strain components are there, the stiffness matrix would have 81 components. But due to the cross shear, due to the virtue of cross shear, the 9 components of stress matrix are not independent, only 6 are independent. So as this stress tensor reduced to 6 number of elements, so the stiffness matrix also reduced to 6 by 6, that is 36 elements. So that is written here. So in short form, we can write the stress strain matrix as like that. Sigma ij is equal to C ij km into epsilon km, or in vector form we can write this like that way. That's why 36 elements are there in the stiffness matrix. Now you know all these 4 subscripts, writing all these 4 subscripts every time, it makes the calculation more complex. So for engineering purpose, we have rewrite the expression. So we have reduced the subscripts in such a way that this matrix will be written like that. Now 1, 2, 3, 4, 5, 6 in that format. So how to sequence the stresses? The sequencing of the stresses dependent in, we can't take this sequence 1, 2, 3, 4 according to our desire. There is a particular rule for which, by following which we have to maintain the order. So the order is like that. This triangle, these arrows are shown here. So we will start it from here. This is first, second, third, fourth, fifth, and sixth, like that. We have to rotate like that way. So that is the order in which we will consider the stress components. So the XX subscript will be substituted by 1, YY will be by 2, ZZ will be substituted by 3, ZY, this one will be substituted by 4, XZ will be substituted by 5, XY will be substituted by 6, and the corresponding strain. In case of strain matrix, the shear strain, we will consider the shear strain as half of the longitudinal strain. Okay, and by assuming this notation, we can rewrite the stress strain matrix like that way. So we have reduced the number of subscripts here for the simplicity of our further calculation. Now, in regular practice, we can't calculate the stress directly from the experiment. What we can measure the strain using a strain gauge. We can measure the strain from the direct experimental test, and from there we have to calculate the stress. So if I express, so this expression can be written as sigma I, that is equal to Cij and epsilon j. So to find out the stress, we need to rewrite this equation as epsilon j will be C inverse Ij into sigma I. Now to find out the inverse of this matrix, there is a condition that the dead value of this matrix must be not equal to 0. Okay, to become existence, the dead value of this matrix, stiffness matrix, must not be equal to 0, so that we can find the inverse of this stiffness matrix, and this inverse of the stiffness matrix is known as compliance matrix. Okay, to find out the stress from the corresponding strain, we need a compliance matrix, and for the existence of compliance matrix, the dead value of the stiffness matrix must not be equal to 0. Now we will go for finding out the expression for this elastic constant. So we have seen in the generalized Hooke's law there are total 36 elastic constants. So does all these mechanical or structural analysis need all these 36 elastic constants for all materials? We will see gradually. No, this 36 elastic constants is not needed every time. So for that, what we need is strain energy density function. Okay. So the number of independent elastic constants can be reduced further if there exists a strain energy density function. Now what is strain energy density? That is strain energy per unit volume. We all know the general formula, that is W is equal to half into stress into strain. And in our last slide, we have seen that sigma I is equal to Cij into epsilon j. So what will be the expression for W? So W will be half into, so we can write this is sigma I into epsilon I. Okay, and if I substitute the expression for sigma I in that equation W, so we will get Cij epsilon j Ij epsilon j into epsilon I. So that is the strain energy density function, half of Cij into epsilon I into epsilon j, with that property that sigma I is equal to partial derivative of strain energy density function with respect to the strain. Now those material which has a quadratic function of strain energy density function will called hyperelastic material. Okay, and if I rewrite this equation by just changing the subscript, because we can also write, because subscript can be changed all the time, because sigma j can be written as sigma j I epsilon I, we can also write it like that way. In that case, W will be half into sigma j into epsilon j, and if I substitute the value of sigma j in this equation, so it will be sigma j Cji into epsilon I into epsilon j. So that is the sigma we have substituted here. So this expression and this expression is actually the same. So we can rewrite the expression of the strain energy density function like that way also. These two are same. Actually, this one and this one are same. If I subtract these two equations, we can get this equation. The left hand side will be 0. So Cij minus Cji into epsilon I into epsilon j. Now for any deformable material, epsilon I may not be equal to 0, epsilon j must not be equal to 0, and epsilon j also must not be equal to 0. Because if strain becomes 0, that will be a perfectly rigid material, and we are not discussing a rigid material, we are discussing about deformable material. That means these strains are 0. So if strains are 0, to satisfy this identity, this bracket Cij minus Cji must be equal to 0, which leads to the identity that Cij is equal to Cji, which means C12 is equal to C21, or we can say C23 is equal to C32. So these are equal, these are equal. So we can say the stiffness matrix is symmetric. So C12, there will be C21 here, but this C21 is equal to C12. So we don't need to write this one, because these are not independent, rather they are symmetric. So all the 36 constant is not needed at all. The stiffness matrix can be reduced to 21 independent elastic constant, where the strain energy density function exists. Okay, a material with 21 independent elastic constant is called the anisotropic material. Okay, an anisotropic material has the crystal parameter like that. Okay, now does all these 21 independent elastic constant are needed for the other material also? Because we know there are different materials like monoclinic material, orthotropic material, isotropic material. What will be in that cases? So the number of elastic constant can further be reduced by use of plane of material symmetry. We know anisotropic material has no symmetry, so in each and every direction the material property changes. Each and every direction the material property changes. That type of material is known as anisotropic material. So if the material is either monoclinic or orthotropic or isotropic, so the further reduction of these independent elastic constants can be done. So for that we need to know what is material symmetry. So to do so, first we define equivalent elastic directions as those specified by Cartesian coordinate system O and a transformed Cartesian system O dashed. We can write this as x1, x2, x3 as three axes. We can write here x1, x2 and x3. This is the transformed condition x1 prime, x2 prime and x3 prime. This is the transformed coordinate system. Now we will assume that the elastic constant Cij, the magnitude of the elastic constants, are unchanged by transformation between these two sets of axes. Only the changes will be in the stress tensor and strain tensor. Okay, because that depends on the material behavior, and the Cij will remain unchanged. Now, how many types of material symmetries are there? If the transformation represents a rotation about an axis, we say the material has axial elastic symmetry with respect to the axis. And if the transformation is a reflection of the axis with respect to some plane, we say the material has a plane of elastic symmetry. So there are two types of symmetry. One is a rotation symmetry with respect to an axis, and another is a plane of elastic symmetry. So one is axial material symmetry, another is a plane of material symmetry, elastic symmetry. So what are they? So as there is some transformation is taking place from one coordinate system to another coordinate system, we need some transformation matrix. So how to find out the transformation matrix? The relationship among the various components with these coordinates, two sets of coordinate system, is known as transformation equation, and the transformation equations can be written like that way in the vector form. In the matrix form, it can be written like that way. Now this 3 by 3 matrix is the transformation matrix. So how to find out this transformation matrix? So for that, we have written the transfer. Here we can see two coordinate systems are there. One is the original coordinate system represented by x1, x2, x3. Another is the transform coordinate system, that is x1 prime, x2 prime, and x3 prime. This is the transform coordinate system. Now, to find out the transformation matrix, we need to write all the unit vectors of transform coordinate system vertically here, x1 prime, x2 prime, x3 prime, and all the original coordinate system here, x1, x2, and x3. Now let us consider the angle between the x1 prime and x1. The angle between the x1 prime and x1 is alpha 1, 1. So a11, which is written here, that is equal to cosine of alpha 1, 1. If the angle between x1 prime and x2, x1 prime and x2, if the angle between x1 prime and x2 is alpha 1, 2, so we can write a12 is equal to cos alpha 1, 2. Similarly, if the angle between the x1 prime and x3 is alpha 1, 3, so we can write a13 is equal to cosine of alpha 1, 3. In such way, so a21 will be the angle between the x2 prime and x1, alpha 2, 1. So a21 will be cosine of alpha 2, 1, like that way. So finding all these cosine and find out this transformation matrix. Okay, that is the way to find out the transformation matrix. Now a simple example will make it more clearer. So we have taken two examples. One is about rotational symmetry. So in this case, consider a 90-degree counterclockwise rotation about the x2 axis. So the x2 axis has given a rotation in the counterclockwise direction 90 degree. So what will be the transformation matrix? So in that case, first we need to find out the angle between x1 prime and x1. So that is the x1 prime and this is x1. So this is the angle. So it is 90 degree. So we need to write here cos 90 degree. So that is 0, we know. Second, we need to find out the angle between x1 prime and x2. So what is x1 prime and x2? So let me take another color. So that is x1 prime and this is x2 axis. So this angle is also 90 degrees. So again here it is cos 90 degree. So this is also 0. Now the third one is x1 prime with x3. x1 prime with x3. So here you can see this is the angle from x1 prime to x3. That is 180 degree. So it is cos 180 degree. So that is -1. So x2 prime and x1. So here we can see x2 prime and x1, that is 90 degree. So cos 90 degree, that is 0. x2 prime and x2, x2 prime and x2 superimpose over each other. That means the angle is 0 degree. So it is cos 0 degree. That's why it is 1. x2 prime and x3, x2 prime and x3, it is 90 degree. It is 90 degree. So cos 90 degree, that is equal to 0. x3 prime and x1, x3 prime and x1, they also superimpose over each other, x3 prime and x1. So that is cos 0 degree, that is equal to 1. x3 prime and x2, so x3 prime and x2, there is again it is 90 degree. So cos 90 degree, that is 0, and x3 prime and x3. So x3 prime and x3 is this 90 degree, because here x3 prime is there, x3 is here, so it is 90 degree. So cos 90 degree, that is 0. In that way, very easily we can find out the transformation matrix. So similarly for reflection, we have taken a reflection about x3, x2, x3 plane. That means if we put a mirror here on the x2, x3 plane, if we put a mirror here, the reflection of x1 will be here. Now again, we can find out the angle between x1 prime and x1, that is 180 degree. So cos 180 degree, so -1. x1 prime and x2, x1 prime and x2, that is 90 degree. So cos 90 degree is equal to 0. x1 prime and x3, x1 prime and x3, this is also 90 degree. So this is cos 90 degree, that is also 0. In the same way, we can find out the transformation matrix for any plane of symmetry. So what we have seen, how to find out the transformation matrix for rotational symmetry and how to find the transformation matrix for plane of symmetry. Now, how to transform a Cartesian tensor using this transformation matrix? What is the rule? The transformation of Cartesian tensor, because ultimately we need to transform the stress and strain using this transformation matrix. So if this is the original coordinate system x1, x2, x3, and if this is the transformed coordinate system x1 prime, x2 prime and x3 prime, so that will be the transformation matrix. We have understood what how to calculate this transformation matrix. Now using this transformation matrix, how to transform a tensor, that means how to apply this transformation matrix to transform a stress tensor or strain tensor. The general rule is to pre-multiply the transformation matrix with the tensor and post-multiply the transpose of the transformation matrix with the tensor to find out the transformed tensor. So that is the rule. So pre-multiply the transformation matrix with the tensor and post-multiply the transpose of the transformation matrix with the tensor to find out the transformed stress tensor or transformed strength tensor. Now we will go for the first material symmetry. So symmetry with respect to a single plane. So those anisotropic material which has only one plane of material symmetry will be called as a monoclinic material, and the corresponding lattice parameters will be this. So monoclinic material, only one plane of symmetry. So let us consider the plane is x1, x2 or x3 plane. So this horizontal plane of symmetry. What does it mean? If this is the material, if the horizontal plane which is situated at the middle, if you see on the screen, that is denoted by a dotted line, blue dotted line, this is the middle plane of that material. If the material is symmetric about this plane, so we can say the deformation behavior about at the bottom direction and the downward direction will be the material, same will be material behavior in the upward direction. That means the material behavior in the downward direction will be same as the material behavior in the upward direction. So that is first material of symmetry, and that type of material is known as monoclinic material. So if this is the plane of symmetry, we know the reflection of this x3 plane will become here, and x1 plane transformed plane will be coincide with that, and x2 axis will be transformed, x2 axis will coincide with that, and the corresponding transformation matrix will be this one. So we already have learned how to calculate this transformation matrix. Now using this transformation matrix, how to transform the stress tensor and strain tensor for monoclinic material. So this was the stress tensor for original coordinate system. This is the transformation matrix, and this is the transpose of the transformation matrix. And after this algebraic calculation of this multiplication of tensor, we can get the final result like that. So we can see this is the transformed stress tensor. So transformed stress tensor is only the sign changes for sigma 4 and sigma 5. And the remaining stress, sigma 1 remains same, sigma 2 remains same, sigma 3 remains same, sigma 6 remains same. Only the changes has been taken place in the direction of sigma 4 and sigma 5. They too becomes negative. Similarly, this is the stress tensor in the original coordinate system. This is the first transformation matrix. This is the transpose of the transformation matrix. And similarly, strain also changes has been taken place in these two components. Now the most important part, how to find out. So this is the Hooke's law for original coordinate system with all the 36 constants, O, x1, x2, x3. And this is the generalized Hooke's law for transformed coordinate system, O, x1 prime, x2 prime, x3 prime. The first equation of this sigma 1 can be written as C11 into epsilon 1, C12 into epsilon 2, like that way. This is the first stress equation, rectangular component of stress equation using the original coordinate system. And this is the equation for the first stress of the transformed coordinate system. Now we have seen the material is symmetric about this plane. That means the material behavior will remain same in the downward direction as well as in the upward direction. That means the stress value have to be same in the corresponding coordinate system. Due to change of coordinate system, the stress must not have changed. It should have the same value because the downward direction stress behavior and strain behavior must be equal to the stress behavior and stress behavior in the up. C14 and C15, these two coefficients become equal to 0. Then only these two equations will be equal. That means the stresses will be equal. Okay. So that is the first conclusion from the first equation. So by considering the next 5 equation, if I imply this concept for all the remaining 5 stress equations, we can find all these elastic constants will be equal to 0 for the first plane of symmetry. Only one plane of symmetry, x1, x2 plane. Okay. So if all these elastic constant becomes 0, the stiffness matrix will be looking like this. Now if there is also strain energy density function, the matrix will be symmetric. So this will be the final matrix for monoclinic material. So in case of monoclinic material, we don't need 21 independent elastic constant, rather we need only 13 independent elastic constant for monoclinic material. That means which has only one plane of symmetry. So only 13 independent elastic constants are needed for monoclinic material. Now can it be further reduced? Yes, it can be further reduced. If we take two orthogonal planes are in symmetry, that means this horizontal plane as well as this vertical plane. These two planes are symmetric. That means in this graph, the downward direction material behavior in the downward direction will be equal to the material behavior in the upward direction for this blue color of plane which is in material symmetry. If I consider the red color plane of material symmetry, so we can say the right hand side material behavior will be equal to the left hand side material behavior. But remember, this material behavior in the right hand side direction is not equal to the material behavior of this upward direction, because upward direction is mutually equal to the downward direction, and this right hand direction material behavior is mutually equal to the left hand direction. But this direction is not equal to the right hand side material behavior is not equal to the left hand upward direction or downward direction. Keep in mind. So how to find out the how many number of independent elastic constant needed for the material which has two material symmetry, two plane of symmetry. For this blue plane of symmetry, this will be the transformation matrix as I have told you earlier. So we can find out the transformation matrix. So using this transformation matrix, we can first transform the tensor, stress tensor and strain tensor. So this is the first transform tensor considering the blue color of material plane of symmetry. Now next, for red color of plane of symmetry, this is the transformation matrix. We again have to transform the tensor using this equation, and this is the final transformed tensor, stress tensor or strain tensor. Now using the generalized Hooke's law as the logic we have applied earlier, so equating the sigma 1 from the original coordinate system and sigma 1 dash from the transformed coordinate system and making them equal, so we can find out the remaining elastic constant will be reduced and only 9 independent constants will be there, where two plane of symmetry are there in a material. So only 9 independent constants will be there. So there was initially 36 number of elastic constants. If we consider the strain energy density function, the matrix become symmetric, so it reduced to 21. Now, if I consider the single plane of symmetry, it reduced to 13 number of independent elastic constant. If we consider the two plane of symmetry, the further it reduced to 9 number of elastic constants. Okay. Now, if there are three plane of symmetry, that means all three mutually perpendicular planes are in symmetry. That means the behavior in the upward direction, material behavior in the upward direction will be equal to the material behavior in the downward direction. Material behavior in the right hand side will be equal to material behavior in the left hand side. Material behavior in the frontal side will be equal to material behavior in the rear side. But they are not mutually equal. That means the right hand side is not equal to the upward, not equal to the backward. So they are independently, axially they are same. So if I consider this, if I transform 3 times the stress tensor and strain tensor, and by applying the same logic, we can find out only there is no changes or no further reduction takes place. This type of material which has 3 plane of symmetry is known as orthotropic material, and these are the lattice parameters for orthotropic material, and there are total 9 number of independent elastic constants. 1, 2, 3, 4, 5, 6, 7, 8, 9 number of elastic constants which are independent. So orthotropic material has 9 independent elastic constants. Now come to the last one, that is the isotropic material. So what about isotropic material? So the reduction of orthotropic elastic matrix to the isotropic matrix may be completed by successive consideration of 3 axes of elastic symmetry. By rotation of 90 degree about x1 axis, followed by a rotation 90 degree about the x3 axis, and followed by a rotation of 45 degree about the x3 axis. So I will describe it step by step. So isotropic bodies, which we have learned in our basic strength of material class, it has no directional property. That means in all direction the properties are same. But in orthotropic bodies, we have same. In the orthogonal direction, the properties are same. As we have seen, in the perpendicular direction it is same, in the horizontal direction it is same, and in the frontal and rear direction they are same. But horizontal direction property are not equal to vertical property. Now if I give a 90 degree rotation along the x1 axis, that means you can see, if we see this side, if I rotate this block like this way, the right hand side property will be equal to the top property, and the left hand side property will be equal to the bottom property. That means all these 4 directions will have the same property. Due to the first rotation 90 degree about the x1 axis in the anti-clockwise direction, it will make all these 4 directions of same property. Okay, so for this transformation, the transformation matrix will be like that. And by applying the previous assumption and previous logic, we can find out these elastic constants will be equal. That means by using this transformation matrix, first we need to transform the stress tensor, then we need to transform the strain tensor, and we need to use the generalized Hooke's law to find out the general equation for sigma 1 and sigma 1 dashed for transform coordinate system, and making them equal. All these, implementing all this logic, we can find out C12 will be equal to C13, C21 will be equal to C31, C22 will be equal to C33, C23 will be equal to C32, and C55 will be equal to C66. Okay, the next one. So next one is written as 90 degree rotation of the x3 axis. So in that 4 side we have equate all these properties, but the frontal direction and the rear direction, they too are still different. So if I give a rotation in the x1 axis, x3 axis in the 90 degree rotation, so if we give a rotation here, so this frontal plane property will be equal to the right hand side property, and this backward plane property will be equal to the left hand side property. That means all these properties in the 4 sides will be equal. which means in our previous assumption all the top, bottom, right, left were equal. This one, this one, this one, this one was equal, and after this rotation all these 6 directions, the properties will be equal in every direction. Okay, so for this rotation the transformation matrix will be like that, and using this transformation matrix we need to transform the stress tensor, strain tensor, and then write down the generalized Hooke's law for original coordinate system and transform coordinate system. And from here we need to find out sigma 1, sigma 1 dash, sigma 2, sigma 2 dash, and equating all these we can again lead to another equalities, that is C12 equal to C21, C11 equal to C22, C12 equal to C23, C31 equal to C32, and C44 equal to C55. Okay, so the last rotation, why we need this last rotation? Because we have made all these 6 surfaces, all the 6 directions equal property, but diagonally they are equal or not we have not calculated. That means in the diagonal direction whether these properties are equal or not we have not considered this yet. So for that, so it will be clear to you, for that what we need to do, we need to give a rotation of this x3 axis at a 45-degree angle so that the diagonal properties will be equal. Okay, that means which is in that direction, the property which is in that direction, so which is in that direction will be equal to in that direction also, or the property which is in that direction will be equal to in this direction also. That means in all direction the material properties will be same. So this is the last rotation. This is the last rotation we need to make the properties same in all direction. So for this 45-degree rotation of this x3 axis, we can find out the transformation matrix as I told you earlier. So this is the transformation matrix, and using this transformation matrix we need to first transform the stress tensor, we need to transform the strain tensor, writing the generalized Hooke's law for original coordinate system, transform coordinate system, and find out the sigma 1 from here, sigma 1 dash from here, and all the other 5 components are here, and equating them will lead to this equality. Now substituting all these, I am showing you, substituting this one, and this one will lead to this final matrix. Okay, and in this final stiffness matrix we can see only 2 independent constants are there. So for an isotropic material there are only 2 independent elastic constants are there, which is C11 and C12. You can see all the terms can be written in terms of C11 and C12. So these are the 2 independent elastic constants. That's why in our basic strength of material calculation we consider only 2 independent elastic constants. So what are these constants? Now we know that Lamè's constant can be described as mu and lambda. These 2 are the Lamè's constants. And if we set C44 as equal to mu and C12 is equal to lambda, we may identify the remaining Cij's using Lamè's constant and rewrite the elastic coefficient matrix for isotropic material like that way. Okay, so this is the stiffness matrix or elastic coefficient matrix for isotropic material using Lamè's constant. Now from the elementary strength of material we know the elastic matrix, G is the modulus of rigidity, K is the Buck modulus, so and E is the Young's modulus, and nu is the Poisson's ratio. The interrelation between them is given by this, and the interrelation between Lamè's constant and each and every elastic constants are given this. If I substitute all these in the previous equation which I have shown here, if I substitute all these values, we can lead the final equation as this. Okay, we can lead as this equation. Okay, so the stress tensor, strain tensor, and this is the stiffness matrix for isotropic material. Okay, if I rewrite the equation in terms of epsilon is equal to C inverse of stress, so this C inverse the C inverse will be the compliance matrix. Okay, so inverse of this matrix is the compliance matrix, and this is the generalized Hooke's law for isotropic material. This is the generalized Hooke's law for isotropic material. So through this discussion, what we have recapitulated that the generalized Hooke's law has 36 number of elastic constants, and if strain energy density function, it reduced to 21. If I consider the first plane of symmetry for monoclinic material, it will be 13 number of independent elastic constant. If I consider three plane of symmetry, that is orthotropic material, the number of elastic constant reduced to 9. And if I consider the isotropic material, the number of elastic constant reduced to 2. And this is the final form which we use in our regular practice. So that was all about today's discussion. Thank you very much. So if you have any question, you can do it.
Thank you, sir. Thank you a lot for such a detailed presentation, and I'm sure that your presentation has cleared the has benefited the participants and all the faculties alike. Sir, you have clearly explained all the coordinates and its leading to Cauchy stress formula, also the sequencing of the stress and strain components, and leading to the generalized Hooke's law. With all the matrices, you have cleared all the doubts, and so it is a very benefiting and very refreshing detailed presentation, I must say, sir. Thank you. Now I pass on to Dr. Atri Bondopadhyay for the question answer rounds.
Thank you, Somi. And thank you, sir, for your very much interesting and wonderful and obviously a detailed explanation of this very interesting topic. Now, I would like to invite the in-house members. If anyone have any query or suggestions or any interesting thing to discuss with our sir, please go on.
Can I?
Sure, sir. Obviously, you're most welcome.
First of all, I must say, I am remembering my student life at IIT Kharagpur because Supriyo is not a good teacher, he's an excellent teacher. I have gone through different subjects of this particular area because I am a man of structural engineering, and I'm lucky to have this kind of lecture from IIT, ISC, or abroad, US, Britain, everywhere. But now I don't have any doubt that Supriyo is the best. Supriyo is the best teacher to me.
Thank you, sir. Thank you very much.
Teacher to me because the way he started, and immediately I have realized that it is going to happen some magic, because you see, normally this tensor or sometimes tensor calculus and all these things, it is becoming a great barrier to many mathematicians, engineers, scientists also, because they don't try to understand from the basics. That means what is tensor, how it is slowly developed, and ultimately transformation matrix and isotropic, orthotropic. This is the way, this. If any teacher is explaining the complex and important matter, definitely is an important matter. At least I can say in structural engineering, a huge application. We are doing everyday finite element analysis and other things, elastic, plastic analysis. I'll come to that. I've got few questions regarding that in my mind. And we are facing tremendous problem. See, first of all, to formulate the thing. Second thing, that after formulation, suppose, for example, you are dealing with the generalized Hooke's law with 36 constants. So it is at least 36 by 36. Stiffness matrix will be 36 by 36, and so many elements. So if you multiply by 100 elements, then it will be 36,000. It means big one. So there is the problem that I am not discussing that here now. I'll come to Supriyo for other discussions. You know that when this stiffness matrix is very big, then it is very difficult to manage mathematically, because ultimately you have to inverse, or you do something, or even the transformation. There are huge cumulative error, and this if you go for error analysis, then you will find that your input may be very good, but finally it will be a garbage out because of this error, because whatever so you have to manage that particular complex mathematical problem uh, by many mathematical techniques. uh, so your Gauss elimination is not always true. Then the solution and many other things are the pivotal condensation. So many things are, normally we apply, and ultimately, frankly speaking, that when it is matching with the benchmark problem, then we are becoming a bit confident, because it is not possible for us to validate each and every parameter in a complex situation. But if it is satisfying the benchmark problem, then at least we are happy that yes, it is happening like that. So even if there is some difference, that may be, maybe within 10%, and is acceptable to all. And after, getting the final response in the experiment, there'll be some deviation, and if that deviation is also within, say, 10%, that is also acceptable, because there is factor of safety and there are
Yes.
other considerations. So that is why, the way you explained, if somebody has got a little bit of elasticity background, then his reaction or her reaction will be just like me. You are not only best to me. I have met many professors throughout the world, but today, I am extremely happy, extremely, it is satisfying,
Thank you, sir.
because the way you explain, keep it up,
Thank you,
because
sir.
you are a young teacher, you can make contribute at the highest level. Now, Supriyo, I have got something question in mind, because we are dealing with RCC, being concrete. Now, problem is that, let us first come to concrete, and then I'll come to reinforced concrete. Problem is that in concrete you cannot say it is homogeneous, isotropic, nothing. So it is heterogeneous. So you don't have any option. You don't have any option to reduce anything. So mathematical problem will come. Okay, we will take over that. We will manage that uh, if we can. Now question comes that these theories, what I found, that for metals it is okay, but for a material like concrete, uh, it is very difficult. It's very difficult means what? Why? Because there are bigger particles, smaller particles, and the interface, and the failure takes place through interface. So what is happening? The moment it cracks, that means, suppose if you consider concrete, very small portion is linear, very initial small portion. That is not really always helpful to, develop the design procedure, because you cannot consider the stress at that lower level, and you will not take the advantage of the material capacity, not fully, to a great extent. Uh, People will not accept. So we are going for limit state theory. And limit state theory means beyond elastic limit. And beyond elastic limit means, yes, you can consider plasticity, you can consider this way, and this particular model will be changed, because you have shown us even three models. One is this explained, second, I'll love to listen from you the second part, that is the other one, reversible. And the third one, you said that permanent deformation. The third one. So that will be much more complicated. But when we are dealing with concrete, uh, beyond a particular stress level, very low stress level, the interface cracks. The moment interface cracks, that it's very difficult to take care of all those things and in the constitutive model and go forward. Another thing we do, a simplified thing, that is incremental finite analysis. In incremental finite analysis, we go up to a particular level and then we break the stress strain curve trilinear or more than that, and accordingly we change our stiffness matrix and try to get the answer. But my question is that uh, if we truly speaking, if we really try to consider the fracture mechanics part of it, then it is really challenging.
Yes, yes, sir. First of all, concrete is basically a sorry.
It's okay. Okay.
Yes. First of all, the concrete is basically not a ductile material; it is a brittle material,
Yeah.
and it is a composite material, not a pure material. It
Yeah.
is made. You can call it a ceramic type of material.
Yeah.
Okay, so the deformation of concrete is very much low. So we can't take any. That means in the structural members, those made are metals. They deform much more within elastic limit rather than concrete. So the for the analysis of only concrete or only concrete material, we need to consider the composite material theory, not this pure material theory. And for that large type of deformation, we know as concrete is a brittle type of material, so it can take huge compressive load rather than tensile load. So that's why these reinforcement are needed. So those metal rods are inserted so that it can takes some tensile stresses up to some limit also. For that, the reinforcement has been taken place, and these reinforcements are given in the direction where the tensile stresses are eventually going to act. Okay, if it is a roof, the throughout the thickness of the concrete, we don't put the iron rod in the middle. You know better than me because you are a civil.
No,
You are from your
Supriyo,
yes,
uh,
sir.
this is definitely, the important considerations for structuring here. But I am coming from the strength of material part of it. That,
Yes,
when you said that, uh, it is a highly orthotropic material, and if you have to accept, no other way out. And second thing, then when you are talking about reinforcement, then we are considering reinforcement in our finite analysis linear elements. We divide into linear elements, and
yes,
those linear elements, we are not going into the detail of the steel reinforcement
yes, yes.
inside.
I also don't know
Only
much about
linear.
that.
We are not doing that because then it will be much more complex.
Yes,
Then only linear element, linear elastic element, and uh, the bond between steel and concrete, that we take care of.
yes,
And we consider that there is no bond slip. There is no bond slip. And if there is a bond slip, that also, we have worked on it. If I get time, if you have time, then we will discuss that. One of our students, when I was in Jadavpur, that he is now professor of NIT, Amio Samanto. He also gave lecture here. Uh, so he was the head. So he worked on that.
okay, sir.
He worked on the slip between reinforcement and concrete, and drastically the sectional behavior changes, and the crack appears, and it is a very very common phenomenon because when you are casting a concrete beam, it is not possible to ensure for somebody that everywhere it is same compacted no honeycomb, nothing. It is not possible. So the critical section, uh, for a damaged structure, it is not always at the highest stress level. Rather, you may find that some other area where the honeycombing took place, and even if the stress level is bending moment is not high, it is just cracked. So, my question is this regarding reinforcement, it is a linear element. Fine, we will consider. And the bond also, the concrete and steel, that is also, people have experimented. We will do that also. And after that, when we will assemble the whole thing, means with your linear element, concrete, if we consider brick element, and after that, if your transformation matrix, everything done, and we got a big matrix. And suppose we could solve that matrix. Even then, even then, my question is this: if even I'm going one step forward, that we are using incremental finite element, like that means this test and curve is beyond illustration is divided into 3 to 4 parts segments. That is also I am accepting, but still then, you know, I, I could not really do justice to the cracking part of it. Mean when it cracks, when concrete cracks, then what exactly how this modulus of elasticity is reducing, and it is really theoretically I don't know whether it is possible or not. Experimentally, uh, the Russians they initially suggested in 1930 that this modular ratio ES by EC, that is even they are saying that it will increase by 3 times.
Yes, sir. Actually, that topic covers in the subject called fracture mechanics.
Yeah, yeah, yeah.
Actually, the stress strain diagram which we learned in our basic classes, so that part can be divided into the total graph can be divided into 3 portions. One is the elastic portion that deals with theory of elasticity. One is the plastic region that is related to theory of plasticity, and from the end of the plasticity to the end where it fractures, that falls under the subject fracture mechanics.
Yes, yes.
So we need to deal with that cracks with that subject called fracture mechanics, and it is a huge subject. So I also not know about detail about that. So maybe the answer may be find out from the subject of fracture mechanics.
No, but Supriyo,
Yes, sir.
I met one professor. Probably you have seen his paper in the journal, Bazant. He is in Northwestern University,
Okay.
and I was there for some time. And just opposite to his room, almost diagonally opposite, Professor S.P. Shah was there. He was like me, structural engineer, concrete, this, that. And the Bazant is like you. And whenever I used to ask Professor Ispisha regarding this, he said, I don't know anything, go to Bazant. Whenever I used to ask Bazant about concrete, he says, no, experiment, go to Professor Ispisha. So I think, the Bazant is to me, he is the topmost person in fracture mechanics, in concrete. So why not we combine? Why not we combine? We can do, because you have got that knowledge, ideas, and we have got huge experimental results. Huge. We have not to perform experiments also. But only thing that uh, we don't understand everything like you, because you have done a lot. So mathematical part, okay, we will resolve. We'll talk to somebody in mathematics, right? Like we are doing. In Professor Maiti was there in IIT Kharagpur. I used to go to him regularly. Now he was in Jadavpur previously. Now I tell you, uh, my proposition is this way, that let us not go to very complicated matter initially. Let us take very simple problem of beams, and or even a particular cylindrical chamber under compression, and let us try to analyze that to some extent. And we are regularly conducting experiments, and if we can really say that the stress deformation whatever you are getting in the experiment, which are very close to the our analysis, considering all this fracture everything. Because this is one more thing I must tell you, that the fracture mechanics, whatever done by Bazant and other people, that is fine, excellent. But now the concrete itself has changed. The concrete, ingredients are totally changed. People, the composite strength of concrete initially, maybe 50 years back, they think 20 Newton per millimeter square after 20 it is occurring. But now it is 100 or more than that. There are polymer concrete, and that structure behavior is totally different. So I think that we have got plenty work to do if we take into consideration of this fracture mechanics part. And you know, this is ocean, just ocean. You
Yes.
can do many work. So anyway, uh, you have explained nicely, properly, and I am lucky to have you. Not only me, all the faculty members and those who are watching in the YouTube. And every time, every day, I'm finding that 700, 800 viewers are there in YouTube. So, and I think that at least those who have not dealt with this kind of subject, even to me, it's eye opener, because first he has to understand the basics, and then slowly complicate things. And I believe that uh, this kind of interaction is extremely important for a uh, you know you know higher class of issues. Means I'm not talking about anybody ABC, because I consider Jalopur means HIT is just a mini Jalopur University. So at least to that level, I have got confidence. So if we can take care of our talents, and if you work hard, who knows that another Bajant will be Supriyo Roy. You never know. Thank you very much, Supriyo. Thank you
Thank
very
you,
much.
sir. Thank you.
Atri, please take care of.
Yes, sir. Thank you, sir, and thank you, sir, Roy, sir. Thank you very much for this immensely attractive and intellectual talk. And I would like to pay a very much big respect for that to you. And for question answer sessions, most of the comments are all are of applausive comments for the session only. And sir have asked a very important question, which was from my side also, which was for the concrete only. So thank you for your session, and hope we can work together again in any other occasions future in the future. Okay.
Absolutely. Thank you.
Thank you, sir. Thank you,
Thank you.
sir,
Thank
for
you
your
very
valuable
much.
time.
Okay.
Thank you, sir.
Thank you, sir. Okay.
Now, for the participants, I thank all the participants for their presence. Dear participants, please note that our next session will start at 3 p.m. sharp. It will be a very interesting lecture on the topic of advanced material for water purification by Dr. Pankaj Kumar Roy, sir. Please join the afternoon session 5 minutes prior the scheduled time. Thank you.
Welcome, sir.
Good afternoon, madam.
Good afternoon, sir.
Is it voice is coming?
Yes, your voice is audible, sir.
So presentation mode, no? You have to
Yes,
go.
sir.
Is it
No,
visible?
sir. I think the other person who is presenting the break screen. So I think he has to discontinue. I'm just calling him.
Is it visible? Just I am asking you.
Only your photo is visible, like your video is visible, not your presentation. I think he removed the presenting this thing. You can continue with your presenting.
Your voice is little bit.
Sir,
Yeah.
you can start your presentation, sir.
Okay,
Like
now on.
you can display your presentation so that
Yeah,
we
yeah,
can
one
check
minute.
it.
1 minute. Just I am trying.
Okay.
Okay. So if I make it like this, is it visible, madam?
No, sir, not yet.
Is it not coming? No.
No, sir. You have to select the entire screen while presenting. The options will be shown, only tab like that. You have to select entire screen.
Sharing is showing. Stop sharing.
Yes, sir. Now I can see your screen.
Now is it visible?
Yes, sir.
First slide, second.
No, no. Slide is not visible. Your Gmail account is visible here, sir.
Oh. Okay. Now,
Yet not. We cannot see the slides yet. Just white screen we can see, sir.
oh, white
That's it.
screen.
Yes, sir. I think it will start now. Yes, sir.
Now is it visible?
Yes, sir. Yes, sir.
Next slide is also moving.
Yes, sir. Slides are moving.
Okay.
So just a minute. I'll just give your brief introduction. A very good afternoon, everyone. I, Deepthi Yelanki, Assistant Professor from Department of Civil Engineering at Haldia Institute of Technology, welcome you all back for this afternoon session of 4th online FP on recent trends in civil engineering. The speaker of today's session is Professor Pankaj Kumar Roy, sir, and his topic is Advanced Materials for Water Purification. Professor Pankaj Kumar Roy, sir, is former Dean of Faculty Council of Interdisciplinary Studies, Law and Management. Sir, School of Water Resources Engineering, Jadavpur University, Kolkata. Sir, we welcome you to this session today and thank you for accepting our invitation. Over to you, sir.
Hello, madam. Hello. Hello.
Yes, sir. I think ma'am's voice is not
Is it
audible.
my
Ma'am.
sound is audible?
Yes, sir. Your sound is audible.
But ma'am sound I am not hearing.
Yeah. So some network fluctuation is
Okay,
there.
okay, okay.
That's
Then
why
I
it's
am
happening.
waiting. Okay, okay,
Sorry, sir.
okay.
Yeah.
That's okay.
Am I audible now?
Yeah, ma'am. Yeah, ma'am.
So sorry because of the connection. Sir has guided more than 35 PhD students and more than 150 PG level students. Sir has completed 25 research projects and 40 consultancy works. Sir has published more than 15 books and monographs. Professor Roy has published around 150 papers in international journals and 50 papers in national journals. Professor Roy has delivered lectures as invited speaker in 20 training courses, seminars, and workshops. Sir, we welcome you to this session today and thank you for accepting our invitation for this online FTP and for giving your valuable time to our session. Over to you, sir.
Okay. Thank you, madam. Thank you, the entire department, entire institute, Haldia Institute of Technology, who has invited me as a speaker. I'm really happy to have with us, with your, because I think the participants are also some of the faculty members from Haldia Institute of Technology. I'm on behalf of Jadavpur University welcome you, and particularly the recent trends in civil engineering 17 to 21st July, organized by Civil Engineering NB for Accredited College Institute. So basically, the topics what I have been chosen, since I'm basically civil engineering, but my specialization is environment as well as the water resource and hydraulic engineering. So in that cases, I have been chosen the topics which is very relevant topics, which is the advanced material for water purification. In most of the cases, as we know, because when you work something or when you do our daily activities, because water is a very our you know valuable resource. So particularly when we work particularly in water thrust area, so eh, under that head, under that umbrella, wastewater also is coming. So when you look into the issue, particularly water resource scenario, so one important aspects on that basically is the water quality. So water quality is very big issue for us, because as we know, now not only West Bengal, other state as well, even other than the India country also, water quality is a big issue. So as per Indian standard, since we are in from India, so definitely we are talking about the Indian standard IS 10500 12,012. So drinking quality standards. So basically, in that cases, it has been highlighted there are number of parameters so far the water quality is concerned. Because water quality, when we look into the water resource scenario, because as a whole, if you consider water resource available, because 97.5%, as we know, is a saline water. This is the common thing. So only available resource is the 2.5%. Out of 2.5%, also it is not available for us. So when you divide the water scenario particularly, so one is the surface water, another is the groundwater, and third component is very, very important, which is called the rainwater. Because rainwater, as per the government policy, not only state as well as the central policy, so most of the cases they have been guided or they have been given some guidelines, because harvesting as well as the recharging is the mandatory to some extent. Why? Because in particularly other than the West Bengal, most of the state they are facing a lot of problems so far the water available is concerned. In our state, because we have number of ponds, reservoir, river, and most of the rivers are perennial source. So that's why if you look into the water resource scenario, so to some extent we are not facing, because we are not paying a single drop, not a single rupee or single paisa. So definitely, so in that cases, water resource scenario is a really is a thrust area. Keeping some of the important aspects, it has also come under change climate scenario also. So now question has come, rainwater basically in most of the cases government has given, if it is a commercial, if it is a residential area, some roof area, it depends on the roof area. If your roof area is more than 20,000 square meter or above, so harvesting and recharging is the mandatory. Keeping in mind, because industry, particularly industry purpose, there is no recharging, there is no option for recharging, only they can harvest the rainwater. Particularly other than the West Bengal, other state really they are doing a lot of action plan related to this issue. We people are doing or making, since it has given the guideline particularly based on the roof area, so that's why to some extent it is not a mandatory. So still, this is the time we have to think water resource really is a very, very important. We have to, otherwise it's really is a big issue for us. It will come later on. It's a big problem for next generation. Now the water quality scenario, if you will look into this water quality scenario, in the guideline it is given more than 30 parameters. So for the water quality, particularly when we talk about the potable water, which is called the drinking water. So when we call it the drinking water, so definitely more than 30 parameters to assess or to check as a daily routine wise. So it's a really is a big task. Not only big task, if you compare with the cost, that is also not fit for us. So in that cases, we are looking more than 10 to 15 parameters is sufficient to say at least the water is safe for drinking or not. In West Bengal, most of the districts, we people are facing the arsenic problems, because government of West Bengal, government of India, if you consider the particularly groundwater is a really is a another issue, another problems, because we are extracting the groundwater, but due to extraction, unauthorized extraction, or overdrawing extraction, so definitely it is a really problem we people are facing. If you look into the quality, so arsenic earlier cases it was not too much high most of the pockets. Now in West Bengal, we are really more than 100 blocks have been affected the arsenics. So and fluoride is a big issues now. Iron is a big another issues now. Phosphate is another issues now. Another problems we people are facing, manganese, that is another issue. So
really is a problem, because when we are extracting that, quality wise it was good if you look into the surface groundwater, but problem, since we are extracting lot of water with respect to the demand, so definitely it's really is a problem. So that's why we people are depend on the surface water. But if you look into the surface water, that is also another issue, another problem. We people are doing lot of the pollution, water surface river pollutions, because Naumi Ganga National Clean Ganga missions, they are also doing a lot of projects particular to make it a clean Ganga. Because when we water for our daily purpose, in case of government or environmental regulations, if you are residing metro cities, mega cities, then we people are using basically it's a 150 LPCD, 150 liter per capita per day. So that is the guideline. Another issue, and different guideline it is given. 135 LPCD also it is there. If it is a sewerage system, so major towns and cities. If it is not sewerage systems, then 90 LPCD. And some cases you can use 70 LPCD. If it's a rural area, 55 LPCD. So in different category wise, it has been highlighted. So when we use the water, surface water, particularly the total water as a source, so definitely 80% roughly we can consider as a wastewater, which is coming from toilet flushing, which is coming from human excreta, so kitchen waste. So these are overall is 80% of that value. So that is also is a huge quantity. So when we are generating the wastewater, so that water it contains high amount of organic matter and high amount of bacteria as well. So definitely, so that water it needs treatment. So that treatment we call, if it is a domestic wastewater sewage treatment plant. So obviously after treatment, ultimately we are discharging that water to the what surface water bodies. So now government has decided some of the guidelines and rules also they have given. So when we are generating wastewater, particularly for industry, they are telling you should have treat. Definitely, that is the mandatory. Without treatment, you can't do anything. But earlier it was Central Pollution Control Board. They have given the guideline. So some of the parameters they have given in case of BOD, biochemical oxygen demand, pH, suspended solids, then COD, chemical oxygen demand, then total coliform, fecal coliform. Now two parameters are added, which are called basically total nitrogen and total phosphorus. So these are the 7 parameters as per the guidelines. So it is mandatory to have look into this. So based on these, we are making the treatment systems, and ultimately we are treating the wastewater, and at the end we are discharging that treated wastewater to the water river system or water body. But now that is another. But now we people are also facing problems. We can't discharge not a single drop of wastewater. When we are generating wastewater, I am talking about the industry purpose, not the domestic purpose. Domestic purpose we are generating, and ultimately it is treating by installing some of the treatment system, which is called the sewage treatment plant. Now a separate system it has come up, advanced system also it has come up. So ultimately treating wastewater, and that treated wastewater now it has been decided we have to use for gardening, we have to use for toilet flushing, we have to use for firefighting, we can use for landscaping. So it is one kind of a, it is one kind of a reuse, it is one kind of a zero liquid discharge, which is called ZLD. So that concept it has already been incorporated, it has already been come up, and now we people are that is accepting, and we are trying to incorporate all these things. And industry people are also making this way, but problem only in this case for industry people, they need the land, because when because the quantity which is generating after treatment also, that quantity is so high. So the available requirement might be when you use this kind of purpose, particularly for toilet flushing, then gardening, then car washing, firefighting. That requirement is not matching with the available water. So that's why some little bit water, extra water, it is coming, and that water also now the government has decided. So even that water also you can't discharge. So that's why ZLD concept it has come up. So that is the very small brief way I have been highlighted so far the water resource scenario is concerned. So since my topics is basically it's the advanced material system for water purification. So, in our Jadavpur University, particularly Water Resource Engineering Department or a school, rather it's called the school. So we develop number of treatment systems, a number of filtration systems for removal of arsenic, for removal of fluoride, for removal of phosphate, for removal of other kind of trace metals. So in that cases, basically, I am highlighting some of the issues. So next slide I am showing the novel adsorbents in remediation of hazardous environmental pollutants in light of iron, phosphate and fluoride. I am showing 2-3 pictures here, which is I think it is visible to you. So one is the phosphate in groundwater. Most of the cases we are getting more than 1 milligram per liter. In particular, I am talking about the groundwater. There might be the reason is the this from fertilizers, because farmers are used a lot of the urea DAP, and that from that cases nitrogen phosphorus is coming. So in that ultimately leaching to the groundwater, and in that groundwater, so phosphate value is coming more than 1 milligram per liter. Next issue is this iron. In most of the cases, we observe that more than 15 milligram per liter, basically it has found iron content, which is really is a problem. Next is the fluoride problem also. Fluoride cases also, it is also more than 2 milligram per liter, in particularly in groundwater in some of the districts. And some of the districts are also highly affected. So for the arsenic point of view, more than 0.01 milligram per liter. This value I am showing as because in the guideline it is clearly written, one is the permissible limit, another is the desirable limit. When we talk about the potable water, which is called the drinking water, always we should have follow the desirable limit, not the permissible limit. Kindly keep in your mind, because permissible limit always higher range with respect to the desirable limit. So earlier cases, the guidelines, it was in case of arsenic, so it was 0.01 milligram per liter, it was the desirable limit, and 0.05 milligram per liter, it's the permissible limit. So when we are getting the arsenic value, particularly in groundwater, so definitely 0.01, if it is more than that, it is not called it's a potable water. Always we should have follow less than 0.01 milligram per liter, which is the desirable limit. So like this fluoride, iron also. Then next slide, if we move to the sources of fluoride. Now, if we talk about the fluoride, then what is the source? Natural. One is the natural source, which is called the geogenic source. Another is the anthropogenic sources, as in case of arsenic. So natural source basically is the groundwater. As we know, there is a different formation it has come in case of fluoride, then fluorospar, and different also from food items it is coming. I don't know you people are aware in this issue, particularly in case of fluoride. Our daily food item like Camela, tea, almost all tea, any kind of tea, almost all tea I'm talking about. More than, see the tea fluoride range value, it is 39.8 to 68.59 milligram per liter, which is having fluoride. Almost all kinds of tea. Then supari is the erica is which is the scientific name. Katichu, which is supari. Some people are taking the with betel and nut. Then definitely supari is also is eatable, and that is also having high content of fluoride. 3.8 to 12 milligram per liter. Then tobacco also. Then rice, even daily people we are eating the rice. In that case, rice also having high fluoride, 1.7 to 2.23. Then wheat also, maize, ilachi, cardamom also, it is having high amount of fluoride. So this is the general, not only our findings, even literature also it is showing. So this is a general. So that's why we people are always preferring so not to eat the raw tea instead of not to eat the raw tea. Actually, basically, always try to eat the with milk. Actually, milk tea always better than with respect to the raw tea. That is also is a separate story, but it also depends the type of the. Actually, not only if we say if you eat daily raw tea instead of milk tea, but then next question it has come, so how much glass of tea or how much glass of cup you are eating with respect to your body weight as well as the your daily food intake value, food intake or nutrition, it depends. So generally, that is also another study. It has been carried out by us. So that is a separate study. I am not going. I am briefly. I am talking about this issue from industry also. Some of the things it has come from due to processing of glass, semiconductors, and ceramic power plants. So that is also the sources from anthropogenic. Now effects, as we know, is a common problems. The effect is a beneficial effects, harmful effects, the guidelines it has given. So that is a very common thing. So that I am not discussing in details. Next, broad aspect I am highlighting or I am showing. So is it visible, audience or participants, professors? Is it visible? Slides. Is it
Yes,
coming
sir.
next or next?
Yes, sir. Yes, sir.
Not
All
coming.
the slides are
Hello,
visible.
hello,
Yes, sir.
hello.
All the slides are visible, sir.
All
Hello.
the visible. Okay,
Yes, sir.
thank
The
you.
slides are clearly visible.
Okay, thank you, ma'am. Thank you, sir. Okay. So then magnitude. This basically is the magnitude of excess fluoride contamination problems. So as per the UNICEF report, world report, 25 countries across the globe. So these are the countries which are really the fluorosis problems, which is endemic. And the magnitude in case of India particularly, Ministry of Health and Family Welfare, Government of India 2016 report, out of 28 states in India, groundwater of 20 states is fluoride affected. So that is also out of this West Bengal also there. So next is the magnitude of excess fluoride contamination problem in West Bengal. So particularly first identified in West Bengal, which is Nalhati 1 block within the district of Birbhum. So that Geological Survey of India, which has been investigated, the area which was 600 square kilometer West Bengal. Now the survey covered 107 blocks in 12 districts are found fluoride concentration, particularly which is more than 1.5 milligram per liter. As per the BIS standard, Bureau of Indian Standard, our desirable limit is 1 milligram per liter, and 1.5 is the maximum permissible limit. So almost 43 blocks in 7 districts really is a problem so far the fluoride is concerned. Now, current research, basically, we very recently we have been established a new technology or new methodology, which is based on the material which is locally available, the laterite soil, particularly in Mednipur area, in Shilaboti River Basin. So, in that cases, we basically use is a very local material which is cost also effective, because now the question has come, when whatever you want to develop, that should be cost effective. This is the number one, this is the mandatory, another is the social acceptability. These two things is very very important. So keeping in mind, so we developed one material which is the, one is the red, another is the white, we call is the laterite soil, lithomarked laterite. So which is basically getting in Mednipur area. So under that we developed one project, as well as we established a good journal paper published in Elsevier. So in that cases, I am just trying to highlight how we have developed, how the material we have developed, and how ultimately what is the use and what is the benefit to the society. So basically, this is the general concept. If you see the map conditions, so left, right, both cases in entire, see the fluoride, how it is varying from 0.02 to 1.77 is scattered wise, it is varying. And in that cases, sample also we have been collected, how people are getting affected, particularly skeletal fluorosis in some of the areas really is a problem. So in that cases, this is the pictures what I'm showing. Next, World Health Organization 2017 recommends the maximum fluoride level, already it has been highlighted. So it WHO, it has been highlighted the maximum fluoride level of 1.5 milligram per liter of water. It is recommended by WHO, but as per the BIS standard, because the maximum permissible limit is the 1.5, but desirable limit is the 1 milligram per liter. So that is, if it is a potable water, if it's a drinkable water, so the fluoride level should be less than 1 milligram per liter. Now we talk about basically adsorbent. Since groundwater is highly affected by fluoride, so basically fluoride we are getting as adsorbent. Along with the fluoride, we are also getting aluminum oxide as well as silicon oxide, dioxide, silicon dioxide. So that, because I think if all of you are civil engineering, I think that part, I think little bit you are aware also, particularly when we design any kind of filtration system. There are a number of filtration system. In general, we call it the rapid sand filter, slow sand filter. That it depends on the rate of filtration. Slow sand filter, basically the rate of filtration is varying from 100 to 200 liters per hour per meter square. And if it is a rapid sand filter, which is more higher, 3,000 to 5,000, sometimes it is a 6,000 liters per hour per meter square. But everything is given in manual CPEHEO manual. We are talking about the manual concept, Central Public Health Environmental Engineering Organization manual. So it is written everything. So in that cases, fluoride means filtration system, particularly it depends on the material. Major filtration system, basically we are dealing, one is the gravel, we call is the gravel. Sometimes due to non-availability of material, people are using the stone chips, and then obviously the sand, coarse sand. That sand, in the guideline it is given, even environmental engineering also you people are dealing that also, it is because undergraduate course, it is an environmental subjects are there also, it is also written. And these are the common is a we can call is a curriculum also. So sand fill means is a coarse sand, fine sand, so obviously it depends on the uniformity coefficient. then effective size, then other type of constant it is there. So obviously along with this, silica content is very very important. So for the filtration system is concerned, when you use any kind of filter, always try to see the silica content. As per the guideline, if it is given more than 90% should be silica content. So any kind of sand. So that's why silica, if it is a good amount of silica, particularly in sand, so definitely that sand quality is very good sand quality. You can say, for it removes bacteria, it removes other kinds of also. So that's why in present system as a adsorbate is a fluoride, this one thing, then obviously along with the alpha hexagonal aluminum oxide, then alpha trigonal silicon dioxide. This is the general. Then our adsorbent, which is locally available material, mentioned earlier also, the laterite soil. So one is the white laterite soil, another is the lead laterite soil. So that is our innovation. That is a very brief material. So we have established for removing of fluoride, for removing of phosphate, for removing of iron and arsenic to some extent. But arsenic other also, there are a lot of material also involved. So next is this. This is the very schematic diagram. When you work this kind of particularly project, one is the batch study, another is the continuous study. So batch study is a, because since you people are dealing lot of students and research work is to some extent is a mandatory, so definitely try to make any kind of short filter developed. So this is one kind of a left hand side, it is a filtration system. So it's a very one kind of a filter where raw water is coming and which contains fluoride affected water. Then that water ultimately it is coming and it is going through this filtration system. When you look into this is the laterite soil, our that soil which is collecting from the field. Then laterite soil, after that then we place some gravel, then sand, then again gravel. This is actually from downward movement. Actually flow is from upward to down, and this is ultimately this water is coming from upstream, then ultimately it is going down. First laterite soil it is passing, then sand, and then gravel sand, then gravel, because in between this gravel and sand is also required, because otherwise I will talk about later on why I am putting the sand and gravel. So this is the simple schematic diagram by application of the material which is locally available. So in general, if you look into the right hand side, the best study in different temperature, because when you do this kind of work, it depends a lot of input parameters. One is the temperature is very important. It is written at 301 degree Kelvin. Then contact time means because your water is fluoride contaminated water. When you do any batch study, so definitely contact is time is very important. Means water it is contact with your soil. So obviously contact time, if you do 1 hour, 2 hour, keeping in that, so it will vary the removal of fluoride. So this is that's why contact time is very very important parameter. Second parameter is the adsorbent dose. Means if you consider this thickness, say whatever thickness it is written 25 centimeter, instead of 25 centimeter, if you consider 10 centimeter, means thickness of the column is also reduced. In that cases absorption capacity is also reduced. So that's why adsorbent dose is also very very important. In that cases we have been considered adsorbent dose. Then agitation means, as we know, in particularly environmental subject, you heard one is called is a clarificator. All these things I think you people are accustomed. So rapid mixing followed by slow mixing. This term basically we are using. So this is also important for us to know for agitations. So it depends on the RPM for mixing the entire things. So that's why agitation speed is also important in that cases. So particularly for higher removal efficiency, here agitation speed we have been considered is 200 RPM. So this is the overall result. This is not a single stage the outcome it is coming. Different temperature it has been worked, different contact time it has been worked, different adsorbent dose it has been worked, and different agitation speeds it has been worked. Ultimately, this is the optimum value. These fours are the optimum value both in case of red type as well as the white types. So if you look into the red type, when initial fluoride concentration, if you are showing, if you see the red color, so obviously two, let's see the removal like this, ultimately it is decreasing and not below the 80% or 81%. So but in case of red type, is a white type is a red color. So in case of red type, see the average percentage of fluoride more than 94%. So that is also in different, even more than 20 milligram or 22 milligram initial fluoride concentration. This is the batch study. So in different cases, so zero charge, so now particles have been charged. As we know, in the soil particles there are a number of cations, anions are present, and that also it depends. You have to look into the when you are adding or passing your fluoride contaminated water through soil which is available in the local, so that some of the parameters might be increasing, that also you have to look. So that's why pH is very important parameters. So in that cases pH also showing. So in the left portion A, it is figure some pH data. Then another is the, so that's why it's called point of zero charge, PZC. So basically, what if pH level somehow it is range from 6.7 and 6.51. Acha, someone, if you are writing anything in the chat group, I am not showing. Ultimately, at the end, once my presentation would be over, then question session will be start. I
Yes,
think
sir.
that would be better.
Yes, sir.
Otherwise, I don't know you people are sending something or not. But at the end, better to question. That would be easier for me. Otherwise, in my desktop,
Yes,
nothing
sir.
is coming. Only somewhere I am getting the sound. So
Sir, there's a
sorry for
modulator.
this. Then
Social will
pH
be.
level basically lower than 6.67 and 6.51 is the adsorbent surface. These are positively charged. And when the pH is level is higher than 6.67 and 6.5, then it is somehow it is a negatively charged. From this observation, it was evident that fluoride ion and adsorbent surface were electrostatically attracted and repelled. So you know the fluoride is a negatively charged. So somewhere the pH, it depends on the pH. If the pH value is ranging from this to this 6.67 to 6.5, so definitely is a positively charged, then positive negative is a attraction. Then definitely now it is lower, is some higher value, so it is called negatively charged, then it is a repel. So both the it is functioning. So for the adsorbent surface electrostatically. Then the influence of particle size on fluoride absorption. Here also if you see, so in the vertical axis the removal of fluoride, then particle size is different, because since we talk about the soil particles, so the particle size is very important. So in that cases, removal also varying. So the observation is basically when the particle size is 2 millimeter and smaller, the removal efficiency was 92.99% in case of white sand, when a white laterite soil. In case of red laterite soil is the 95.49% respectively. So ultimately, this is the overall is the concept. Basically, it depends the particle size. 2 millimeter or smaller, the removal efficiency is also higher. Then optimization of adsorption characteristics. So in that case, basically, because in the first slide, 2 3 slides back, if you recall, so here there I have been highlighted or showed it was basically the optimization speed is 200 rpm. Like this, I have already been highlighted. So how it has established, this is the case of optimization, because directly if you put a charge agitation speed is 200 rpm, that's a problem. So that's why how it has established by different rpm. So from 80 rpm to 260 rpm, it's a range value. Based on that, we have got renewable percentage. It has been established from 2, 5, 10, 20. So from here, it has been established 200 RPM is the optimum agitation speed. Like this also, it has been shown the contact time, because contact time also I have been highlighted earlier. 5 hours is the best contact time for best getting the best efficiency, for best removal efficiency. So that's why that also how it has come. So that is also, it is showing the down graph. So overall observation, if you look into this, due to insufficient contact between the pollutant ions and hydroxide flux at low steering speed, which slow down the removal process. So then that's why it was observed that with a constant dose of the that kaolinite lithomarch, basically this is, it might be a white or red, both cases, the amount of fluoride adsorbed on the surface of the adsorbent increased. So ultimately, this is the overall observation which has already been highlighted. Next, it's because when you any kind of things, particularly this kind of things, if you want to develop, kinetics is very very important. Because why it is a, we call it a kinetic, because kinetics means, since we are talking about the removal by using the natural material, so definitely it depends on the characteristics. That characteristics, it could have either physical characteristics or it could have either chemical characteristics. So basically it depends, because when you talk about the removal percentage is higher, always we should have mentioned whether it is based on the fully physical characteristics parameters or fully chemical characteristics parameters, which are responsible for removing fluoride or any kind of things. So that's why kinetics is very very important to establish this kind of things along with this isotherm analysis. So in that cases, we have established, we have been considered pseudo first order, pseudo second order, because first order which reflecting the physical kinetics or physical behavior, and second order basically we call it as chemical behavior. So so in different parameters, pseudo first order, some of the parameters it has been highlighted in the literature. Based on that initial fluid concentration, and ultimately which correlation is better for this overall, is a simple way with a statistical package or statistical analysis. R square is the major value. R square is the value where you can see which correlation or which is more, which one is the most more responsible for removing this kind of things. So R square is the, you see pseudo second order R square value where all are in red, which is average more than 99.9%. So in that cases, we can establish some of the kinetics, which is really it helps to remove this kind of things for absorption and as well as for isotherm analysis. Now we look into the isotherm, because isotherm means when you use any kind of material, one is the kinetics, that part is over, another is the isotherm. Isotherm means that material always it has some absorption capacity, that also you have to establish, because any kind of material it has some limitations. So absorption capacity, to look into this issue, some of the models which are also available, which are called Langmuir nonlinear model, Friendlich nonlinear model, Temkin. These are three basically isotherm model. All are nonlinear equations. So definitely that also it highlights the absorption capacity of particular that material which are using for removing this kind of things. So right hand side it has been given so three models, so that also some of the parameters highlighted by the individual models. So that also where another common parameter which is R square value, that also R square value, and where we can see in case of red soil or in case of white soil, some of the things we have shown Langmuir's equations. White laterite soil R value is higher. Then in case of as friendly red laterite soil is higher. So this is very important. And for observation, if you look as a whole, red type is a multi-layer absorption. White type basically is a monolayer absorption, and strong chemical bond was established between the fluoride ion and the active surface functional group of laterite soil, and fluoride ion diffused into the pores, which is basically mesopores, and some where micropores also observed as a result of interparticular diffusion. So basically red type as a whole, we can say red type is a multi-layer absorption and white type is a monolayer absorption. By seeing this kind of things, one is the kinetics as well as the isotherms analysis. So that earlier it was the best study. Now if you make it is a fixed bed column, which is also is a continuous, that is also you have to check into, because when you develop any kind of filter, that is also it should be continuous. So one is the best study batch is somehow it has been established, the absorption capacity, some kinetics, then contact time, then agitation speed, and whatever. So now if you look into the fixed bed column test, so in that cases we passed 50 liters of fluoride contaminated water in the raw water basically, where 2.37 milligram per liter of fluoride actually was collected from a tube well. Actually that tube well depth it was 150 120 feet within the river basins, and this red type soil also collected from area Mednipur district's Gorbeta. So the overall results, if you when you make it this kind of fixed bed column, so established scientists they have also developed some of the kinetics along with some of the equations. One is the Bohart Adams, then Yoon Nelson, then Thomas. These three models has been considered, where you can find out the sum of the rate constant, where also is a common parameter is R square value. We can see which one is the most uh, prominent value it has come. So ultimately from here we can establish. So if you see the down portion line, the breakthrough point was observed after 3.3 hours basically, is 210 minutes, with removal efficiency is coming 97%. So you can see 3.5 hours continuously when you work your entire filter without any disrupt. So definitely the removal is so high, 77. So approximately if you see as a whole, 1 gram of that laterite soil, your maximum fluoride absorption capacity it is coming 51.33 milligram. So 1 gram of laterite soil if you keep in your filter, so which contains 51.3 milligram, which is the absorption capacity from where the fluoride will be absorbed. So and this is the sum of the characters, because characteristics is also very important, and before and after when you use that fluoride contaminated water and ultimately passing through this laterite soil, that also somehow structural behavior somehow it is changed, and some of the compounds which are available, which are present in the existing soil systems, and somehow it has been observed that elements somehow it is been increased, somehow some of the elements it has been decreased. So in that cases, for characterization is also very important before and after absorption. So elements which are getting or which are found, particularly one is the silicon, then aluminium, then iron, titanium, potassium, fluorine. These are the element, and compound wise also it has been found in the soil. So that one is the red laterite before absorption, before passing the fluoride water. So weight is also it has been measured percentage wise, 66% silica dioxide, then aluminum oxide, then iron, titanium, then potassium, whatever. So ultimately, if you look into the second or third column after absorption, most of the cases excepting silica. So silicon content when it is increasing means it is good for the filtration system. So other parameters is drastically reduced. So this is a good significance for removal, particularly this kind of things. So, and which is one is some of the cases we have seen it's some morphological as well as some heterogeneity material also change significantly, but ultimately resulting the fluoride removal concentration is to some extent we are getting higher. So that is also is a good results. So this is the characteristics graph. So then XRD also we have through XRD also we can see the type of the structures, the formation of the structure, which is very important. That is also we have to see particularly what type of structure it has been established, particularly the bond formation. So XRD also it is we should have to work on it, because when you remove this kind of or when you use this kind of material, so that also you have to look. So XRD, which is reflecting the, we have seen the strong electrostatic force of attraction between the positive and negative ions make the bond stronger. So that is also one of the cases to reduce, to increase the removal of fluoride efficiency. So that is also the XRD results. Then now question comes the reusability. Reusability means or cost analysis. This is very important when you develop any kind of filter, particularly removing fluoride, iron, phosphate, which is very challenging. And now because fluoride removal filter is available in the market, particularly here I want to highlight the phosphate removal, which is very challenging, particularly industry cases also. So once you develop any kind of material, so definitely cost is also is important, so already been highlighted. And another thing is this, once you use, because absorption capacity is limited, so once absorption capacity is exhausted, so definitely whether that material at all reusable, the at all there or not, that also you have to look. And when you discard this kind of material, so definitely open ground thrown is not suitable. So definitely there is another issue for environmental problems. So that's why reject management is also very important, because this kind of things once it is not reusable, so definitely then you have to discard, and that discard material you have to do something, otherwise there is another issue. So reusability and cost analysis also it has been established. So we have seen in the fourth stage the fluoride removal efficiency also. If you use multiple time, number of cycles also we have been the absorbent dose. So if you consider, then same material if we removing for particularly fluoride removal, we can use fourth stage. That then also we are getting the percentage average for red type is 82%, then white type is a 72%. So still we are removing the fluoride. So obviously the with respect to the first stage, second stage, that value it was more than 90, definitely it has been reduced, but still we are getting removal. So then cost is also it is coming. So overall cost, if you look into this, the total cost is very very negligible. If you can see in the current study, you can see the cost of sand, gravel. If you cost the entire things, so total cost per liter of filtered water is therefore it is coming 0.125, so which is very negligible. For 1000 liter, you can say 125 rupees. 1000 liters, you can say 125 rupees, which is very negligible value. Now we people are buying mineral water 500 ml is rupees 20 rupees. Uh, this is I am talking about the entire filtration system cost, because that also the material once you are installing everything, so that also not continuous regeneration is doing. So this is the total cost which is coming. So for the filtered water is coming. So this is the very negligible value. Then the problem is hard work, biochar. We people are also working number of problem, particularly proving our absorption mechanism of low surface area hardwood biochar and magnesium oxide impregnated feedstock for enhance iron and phosphate removal from aqueous solution. So in global scale, what is the problems that I am showing? Then if you look into the phosphorus pollution, now the phosphorus pollution is a big problem. So that also we have already been highlighted. So from sewage water, phosphate is coming. From agriculture also, so phosphate is coming. So the Indian scenario is a phosphate is a big problem. Ultimately, groundwater which is being contaminated by phosphate. So this is the phosphate issues, and that is also acceptable. WHO it is acceptable. 0.1 is the acceptable or desirable limit. Permissible is the 1 milligram per liter. The farmer is different zone. It is varying phosphate value from 0.01 to 1.03 milligram per liter. This is the entire range of phosphate contamination. So in basin wise we have seen it. This is the major area where phosphate people are getting. So now for absorption of phosphate in aqueous phase using biochar. So basically that also another work. Basically this frequently used adsorbents is a literature. Basically past literature it is showing rice husks is very good for removing this kind of things. Sewage sludge before centrifuge. Actually before centrifuge means when you extracting the water. So before centrifuge means it mixing both solids as well as the liquid. So this is another adsorbent. Then corn cobs, this is another adsorbent. Then sugarcane bagasse is another adsorbent. Then maize straw is another adsorbent. Then soybean stover. This you people are doing this kind of material using is a good adsorbent. All are good adsorbent. Eggshell is very good adsorbent for removing phosphate as well as the iron and other material also. Rice straw. Then peanut shell also is very important. So this is the biochar type. Actually, we have used corn straw, then wheat straw. This is one of the table which is showing here the phosphate concentration. If it is 2 milligram per liter, before it was 7, then after it is 2 milligram per liter. Like this, it has been reduced actually, but particularly corn straw, which is more effective with respect to the wheat straw. And particularly absorption of phosphate in aqueous phase using biochar also, how it has been prepared basically is the current study. Hardwood some ports is 500 micrometer to 1.15 millimeter actually. That is also the size, very low cost and environmental friendly basically. So that also used as a biochar. And basically this selection basically is Shoria robusta is a shal, is one kind of a tree found in the Indian subcontinent. As you know, it's an important source of hardwood timber. This is using this kind of material we use as a biochar for removing phosphate or phosphorus. So general is a characteristics is very important. Is a basically generally left hand side is a hardwood characteristics, and see the surface area, then the total pore volume, micropore area, then the external surface area, micro pore volume. So these are the parameters in case of hardwood. And right hand side, magnesium oxide, MgO present hardwood basically. In that cases, surface area is higher, so total pore volume is also higher. Then micropore area is also higher. So then micropore volume is also higher. Sodium, phosphorus, sodium, these are all present in the hardwood. In right hand side, if you look into this magnesium oxide, oxygen is more higher, calcium is also higher, then manganese also, then potassium, then chlorine. These are the elements which are present in the raw material. So this is the general XRD test, degree of crystallinity, then amorphous content. So this is also required to get the good amount of absorption. So in that case, batch absorption study we also conducted by using different types of tubes. And basically, the entire test has been conducted by IC ion chromatography, which is available in our laboratory. So then some of the graphs which have been established, contact time with respect to the contact time, then agitation speed and adsorbent dose. Earlier also these are the varying parameter, because this is also important. One is the MgO hardwood, another is the normal simple hardwood. So that also we have showing here, blue color as well as the red color, so with the phosphate removal efficiency with respect to the phosphate concentration. Then effect of adsorbent dose, like different concentration we have been considered. Then ultimately contact time, agitation speeds. So to actually mainly for optimization, so particularly contact time as well as the agitation speeds, we have to work in that way. Then phosphate adsorption isotope. So similar way, because earlier, if you understand the earlier concept, same concept, because one is the kinetic study as well as the then isotope models also, it is important to look into this, the absorption capacity. So in that cases, Langmuir, Svenville, Temkin, Elovich is another model for this. Then Dubinin is another model, isotope DR models. That is also we can apply. So these are the available in the literature, where you can establish some of the constants based on the different models, and ultimately you can establish which method or which models is more accurate to your general results. So in that cases, R square value also we are getting higher in case of Langmuir isotopes, and Temkin also you are getting. So like this, you can establish which correlation or which model it has been more fitting with the equation. So finally, we have received the adsorption capacity per gram of hardwood. We can say the adsorption capacity is 828.82 milligram. So this is the phosphate absorption on the particularly MgO hardwood surface was combination of mono as well as multi-layer absorption. So like this kinetics earlier also we have been already been discussed, because kinetics as well as the isotherms both are needed to establish this kind of things. Then iron, same things. Then iron, if you look into the iron, because see, we are talking about the problems, we are not talking about the only problem, we are talking about the technology. Once it is present, how to remove based on the cost effective social acceptability. This is because as an engineer or as a technical persons, so always try to develop some of the things which is more usable for the local people or particularly the beneficiary which are really problem facing, daily facing. So that's why cost effective technology is very effective, very essential. So like this iron also, how to remove the iron removal by using wood, by wood char, same things. So same manner we have established by different only problem is, only issue is this: when you're removing particularly iron here, biochar is particularly, we have seen earlier, banana peel is very important, very good for making a biochar, and date palm also is a very good material for biochar, that also you can use. The reason is this: this kind of material when you use is a low one, is the low cost absorbent it would be. And when we have seen the FTIR relation data with by using the machine, so definitely where we have seen the strong binding capacity, particularly cations in the aqueous phases due to the presence of carboxyl group. So iron is a, since iron is a positively charged, and obviously, and carbon is a biochar is a negatively charged, and has a high electrical conductivity. So that's why removal is a very good. So in that cases, you can use different material as a biochar. So I like in that cases also we have established the agitation speed, the optima agitation speed, optima absorbent dose also. And then same model. Then here you see the right hand side. This is the base fitted, and then Langmuir. So isotherms, then kinetics, these are all already been discussed. Similar way you have to establish. Now arsenic. Arsenic issue is another issue, is a problem also. Here one things I am showing here is by using the iron nail. By using the iron nail, because rusted iron nail is very important for removal arsenic. Is because rusted iron nail which contains high amount of iron, so that also helps to remove the arsenic. So in that case, a very few materials have been used. The rusted various materials of filter media, so rusted iron nails, then gravel, then sand. These are the three materials where you can use for removal of arsenic. This is one kind of a candle filter, or left hand portion. You can see this is the filter candle, that arsenic contaminated water, it is coming from upper, then and going down from this the treated water, which is arsenic free water. So in the filter column we have used the nail, iron nail, then sand, then gravel, then sand. So ultimately the treated water, it is coming through this downward pipe. So as we know, the arsenic content, arsenic value is the permissible value is 0.01 milligram per liter, which is 10 microgram per liter. This is the acceptable limit. So obviously, all outcome result it is coming. Actually, it depends on the how much water you are treating. When you are treated more than 60 liters or 65 liters, then the absorption capacity is exhausted. So in that cases, it is coming the higher value. So obviously in that cases you have to change your replacement, or you have to wash your material for reusability. So like this, another kind of material which is also people are using for excess fluoride. Earlier we have shown it that, and another material which is resin, that is also available in the market. You can buy some of the material, resin material, which one is a cations and both the resins you can use for removal fluoride. That is also I am showing here. So here also one filter candle by using simple burette. Here material also you are using, then upper portion, down portion is the sand, gravel, and cation, anion, both resins you have to use, because otherwise if you look into the removal percentage, to some extent we are not getting the higher. So that's why both cation, anion exchange resin filter, that also you have to use for removal the fluoride. So like this fluoride value raw, if it is a 5.5 milligram per liter, then filtered water it is coming almost zero, or zero it is. So like other only problem it was Separately, if you may run the filter, so cation, anion. So in that cases, pH value somehow drastically it has been reduced. So that also, if it is, you should look into this issue, because pH, or if it is reduced less than 6.5 milli 5, so definitely is a great concern. So in that cases, it is a totally acidic range. So then you have to that's why combine effect cation anion resins. If you add it, combine, then you add or make it a filter along with gravel and sand, then the performance is very good. In that cases, the pH is also to some extent it is within the range. Some is a potential. So overall, if you look into this, the overall current research work, because this kind of things already been we have developed, and the fluoride removal that by using this kind of laterite soil. So then the MGO hardwood also it has been used as a biochar for removal of phosphate. Then some of the that iron also using some of the that material like banana peel and other kind of coconut shell as used as a biochar, that also very effective for removal of iron. So in that cases, any kind of material as a researcher you can use, and it is a very good material as an advanced material, and which is very cost effective also and socially acceptable also. Keeping in that, so I am ending my presentation now. Question session. Thank you.
Sir, quickly, I'll give the vote of thanks. Then we'll continue with the question and answer session. Is it okay with you, sir? Hello, sir. Can you hear me?
Yes.
Okay.
Yes, madam.
Okay. Thank you, sir, for your informative and interesting deliberation on the topic advanced materials for water purification. We, the faculty members of Haldia Institute of Technology, as well as all our participants, are very happy and overwhelmed with this session. Professor Roy has discussed important points and aspects of water purification. In his session, Sir has discussed how water resource scenario is a thrust area and why harvesting and recharging is important in some of the Indian states. Sir emphasized on the parameters for assessing water quality and the problems in using surface water. Sir also discussed about the novel absorbance in remediation of hazardous environmental pollutants like iron, phosphate, and fluoride. Magnitude of excess fluoride contamination problems and how laterite soil helps in its removal. Sir had graphically shown us how red and white type of laterite soil affects the removal of the fluoride content in water. Sir also spoke about reusability and cost analysis of filters. Sir deliberated about phosphate and iron contamination issues and adsorption of phosphate and iron in aqueous phase using biochars. Removal of arsenic from groundwater using rusted iron nails, gravels, and sand seemed very interesting, sir. I think this detailed discussion will help our participants to enhance their knowledge in advanced materials used in water purification. Sir, your presentation was very well organized and detailed with a understandable language for all of us, and with all the real time images that you used was very nice and attractive, sir. So again, on behalf of the organizing committee, I am thanking you, sir, for this important discussion. Thank you very much. Now I would like to pass on to
Dipti,
Dr.
Dipti,
Hello.
I want 5 minutes from you.
Okay,
I
sir.
want
Sure. Sure, sir. Carry
finish
on.
for you.
Carry on, sir.
Video is not working. First of all,
Sir, your sound is not.
that's the thing. I
Sir,
was
I am
in
not
this
listening.
meeting. It's working. I don't know what is the reason behind it.
Sir, your
The sound
voice is
is
breaking, sir. Hello.
It's true. Yes, that I can understand.
Yes, sir.
But what to do then? What to do then? Hmm, I'm not getting it. Maybe the internet support is not that good.
Yes, sir.
Maybe. But I can. Is it now better? Is it better a bit?
Yes, sir. No.
Uh, Slightly better, maybe.
Yes, slightly better.
Because uh, slightly better, maybe.
Yes, sir. Yes, sir.
Um,
Carry on, sir.
Professor Roy, yes, we discussed a lot on this. I was listening to him in the beginning, but after that, my internet problem started.
Yes, sir.
I could not continue, but again, I'm trying to, connect to end this problem. I don't know whether Professor Roy can hear me or not.
Yes, sir. I'm hearing.
Uh, so I thought, you know, making the video.
I think there's a bad internet connection. So let's continue with question answer session and then let Somnath sir continue with his talk. My colleague Dr. Bandopadhyay will continue with the questions in the chat section.
Thank you, ma'am, and thank you, sir, for this wonderful and awesome session. And I really means very much interested on whatever you have shared, and this is so much beneficial for even someone who is not from the field of structure. I mean, not from the field of your environment and this thing can easily understand the importance of this session. So thank you very much for this wonderful knowledge sharing session. And now for the question answer part, may I invite all the faculty members of in-house who have joined the session and the participants for any question. Please go proceed.
Hello, sir. Good afternoon.
Good afternoon.
This is Soikat Song. I have a few questions regarding this presentation. So first is, how do you manage to use the adsorbent after the adsorption?
Actually, thing is this. That's why I mentioned some of the cases. Reject management is very important. Reject management. When you removing anything, ultimately the entire things it has been absorbed in that material. So that reject is another issue. So I am not highlighting here. So once it has been used, that also you have to handle in different manner. Like this, when we removing arsenic particularly, that
Yes.
reject material we are making some of the cases we are trying to develop ornamental bricks, concrete blocks by fixing with this. Then obviously in that cases we have to make it a leachability test. So because when you that break down any kind of material when you making, so definitely it's a leachability test also when you fixing. So in that cases it is not a harmful. So in that way it has been managed reject material also. So this is because absorption it is done because this is not the continuous, because after 3 years, after 4 years the material will be changed. So in that cases you have to discard the material, and discard is not directly thrown into the open area. Obviously for this is separate management systems that also it should
Okay,
have.
sir. And sir, next one is, how do you determine the pH ZPC?
pH ZPC means that pH value, pH we are talking
Yes,
about.
yes, sir, yes, sir.
No, that is actually what happens actually that pH value basically when you use any kind of material.
Yes,
So that characteristic is very XRD
Yeah.
That FTIR, that characteristics is very important.
Yes.
So keeping that characteristics also, you have to use this, because in raw cases, what is the pH value? Once you passing that contaminated water, in that cases also you have to measure the pH value. So like this is a difference pH, how it is coming. Based on this, the optimum value it has been established, and keeping in that we have been determined that this is the pH where you have to should always kindly keep in your mind, or try to maintain. If it is a higher, so reduction value it is reducing. Like this, you have to establish actually.
Yes.
Two things
Yes.
so you have to one is the FTR value, another is the XRD. Then
Yes.
also.
Yes. And what kind of absorption is going through in this whole process?
So 1 minute, Professor Somnath Ghosh is phoning me. 1 minute, sir.
Okay, sir. Okay. Okay.
Yes, sir. Yes, sir. Yes, sir. Yes, sir. Okay, sir. Okay. Take it. Take it. Okay. Sorry, sir. Please repeat once more. Your question, last question.
Yes,
Unmute
sir.
yourself.
My last question was what kind of absorption is taking place in this whole process?
What kind of absorption?
Is taking place.
What kind of absorption is taking place means, that's why is absorption basically see. Now depends on the type of the element, type of the so if it is a fluoride is a negative charge particle. So like this, negative positive is a attraction. So
Yes.
in that cases, when you use laterite soil, the laterite soil is a different types: red
Yes.
laterite, white
Yes.
laterite. So red laterite, some cases we have seen positive charge particles, so it's getting higher. So this is a one kind of a electrostatic force, means negative is the attraction force. So in that case, it is a bonding to get the better, to get the higher silicon dioxide. So it's a one kind of a, you can see, chemical reactions. So that's why pseudo second order R square value is higher. So
Yes.
it's not like a physical property. There is no porosity or pore space. It doesn't depend. So physical parameter to some extent is not a higher extent or higher to help to remove the higher concentration of particularly whether it's a fluoride, arsenic, whatever. So always we have seen is the chemical property is always better to remove better concentration actually. That's
So,
why pseudo second order value is always higher value.
so that means chemical absorption is going on over here.
Solution is great.
Okay, sir. Okay, sir. And another question from our listener was that is that laterite soil is the only adsorbent fluoride
No,
content
no,
in
no, no,
the
no, no, no. No, this is one kind of a ester. No, no other material also. Resin also. You have last slide. I have seen resin. It is also locally available material. Resin cations and resins also. By using resins also, we can remove fluoride also. But this is the local material which is available and is
available?
cost
Yes.
effective also.
Yes. Yes.
All values. So that's why I'm saying other materials. That is your research. You can also work. Lot of
Okay.
literature also available. You can also work other kind of material also.
Okay,
Even
sir.
some of the solid portion, solid area, particularly fluoride. Only soaking is the only method. No need to do any kind of things. Only soaking.
Okay.
20 hours soaking.
Okay.
So suppose any kind of suppose vegetables which contains high amount of fluoride. Now that vegetables, if you soak for 20 hours, so
Yes.
next day totally fluoride concentration is drastically reduced. So soaking is the only method in that cases. So like this, different ways or different methods are there.
Okay, sir.
Thank you very much
So,
for waiting me. And now I think the internet problem is a bit resolved. First of all, I must say that that today we have really received a lot from Professor Rai, because he is working extremely hard for a long time. And I found that when he was dean, at that time also
you are
he,
also being sir.
he was, he was involved in the research deeply, not only administration. And frankly speaking, uh, what I wanted to discuss that uh, in HIT in Haldia, just few months back, we have we had rather organized one workshop where you know that Tadit actually he came, you know him, no? School of Environment Engineering,
Yes.
and we had a discussion on that. Means basically the discussion is around the work he has done, and today our faculty members and others they are listening to you also. Now after that workshop, we actually you know developed a group, environmental group,
Yes.
and this in the environmental group, whatever the job means work, research work, uh, Tadit Rajuri is doing, or you are doing, or here your Bijoli Mondol is doing, or Radharani Das in chemical engineering they are doing, and Shoikot also participating in many research work. So what we decided, we framed a group of say around 10, and there many times uh, you know your name is proposed, and Ashish, his name is also proposed, and Tarit actually. So now the time has come, because already everybody listened to this kind of thing. Time has come that this group should work together.
Yes.
Means you, Pavitra Chaudhary,
Yes.
Ashish Mojumdar,
Yes.
and from Bijoli, Radharani Das, and the Shoikat Shom. So our intention was initially, uh, it is uh, fluoride is good for teeth. Everybody knows.
Yes.
But too much of fluoride is bad.
And then,
That you know. So that's why you have explained nicely everything. Uh, but truly speaking, whenever I discuss with Torit or anybody else, this we don't have very clear picture of the Midnapur district. It is there. Many they have quoted that in Midnapur arsenic problem is not there, fluoride problem is not that way visible. But if we take up a project on Midnapur district and examining the arsenic, fluoride, and other things, and another person in HIT, he is with food technology department. Today he is not here. Gaurav. He said that that the whatever chloride we are getting at the root level of the tree, and that is sometimes it is very high, but it is possible that in the fruit also it is transmitted.
yes.
So, as a food technologist, he said that why not you are including fruits also.
Yes.
So we can have a discussion, the food technologist, the environmental engineers, and all, chemical engineering, and then finally, if we take up a project on, in Midnapur district, and there'll be a big team. Obviously, we will send a big project to DST or any good organization, and I think at least one district, if we cover in detail
Yes.
in all the aspects,
Yes.
and after that, if we decide that okay, let us do the same thing in the other districts. So this is my submission to you
Yes.
that
Sure. Sure.
if you please,
No, sure,
uh,
sir. If you say anything, any kind of help, if you need from my side, sir, I will be here.
okay. So that is the very nice thing,
Sure, sir.
and you see, have you seen visually? No, visually, please put your video on. Visually, are you there?
Sir, sir, sir. Yes, sir.
Please, put your video on.
Yes, sir.
This is
Of
visually,
अच्छा अच्छा
and in civil engineering department, he is at the present moment associate professor,
ओके
and senior. Maybe anytime
अच्छा
next level he will go.
यस
So uh, he is working. She is working very hard, and Radharanidhi is not here. She is also extremely active, and Shoikat is always with Bijli, this Bijli. Now we have support from chemical engineering. We have got support from food technology, civil engineering, and if required, chemistry. Plus, you know,
what
from you,
yes
Rohit Chaudhary,
yes
and Ashish
sure sir
Majumdar. So if I combine this group and if we can write a big project for Midnapur district,
sure sir
that will be very nice, right? Another thing I must tell you that this is whatever we'll do in future, but you tell me frankly that what is the status of arsenic in whatever you have observed in uh, Purbo Mednipur, means East Mednipur.
yes.
What do you think that the
And arsenic also, sir. Arsenic problems, as we know, present scenario is another great area. Actually, you can say 104 blocks have been affected by arsenic. So, I think that area, what you are telling, also that is also in Nodia districts because they were close
no,
to.
but do you think that because many persons are saying that Purbo Mednipur, this East Mednapur is not that affected by arsenic. Is it
Yes,
true?
actually, arsenic, yes, to some extent, it is not a higher value we are getting. So that's why, in case of arsenic, Nodia district, if you consider, that would be better. And particularly fluoride, phosphate, iron problem, that in that area also it is. So,
And
district, I think it would be better to get a good, to get a big
do,
project, to make it a big project.
do you think that this Paschim Midnapur, the Jhargram, that
Yes,
part,
yes, sir.
it is
Yes, sir.
free from arsenic?
No, no, free from means some of the pockets. The problem is this, sir. Some of the pockets, if you say the particular past literature, earlier it was not there. Now, as we know, people are extracting more groundwater, more groundwater. Might be the same area, same pockets. Now, if you sample collected and tested, might be the somehow it has been come up. So that also, sir, at present scenario, to some extent magnitude it was lesser, but later on, earlier, with respect to the earlier, might be now it has, because the due to not on there is no control so far the groundwater extraction is concerned. Actually. So that's why
Uh,
it's a
you see,
required.
our institute, they have got a policy like that. Charity begins at home.
Yes,
So they want that. Let us take Midnapur first.
yes, sir. Yes, sir.
Of course, you can include Nadia
Sir,
also.
sir,
No problem.
phosphate is another challenging issue, sir. I'm telling you, sir.
Yes,
Because
that
we
is another.
people are neglecting, because as you know, industry people are also generating phosphate also. So ultimately, that phosphate removal is another challenging. So
Okay.
these three: iron, phosphate, and fluoride. So if you take three,
But Haldia is basically there are 40 companies are there. It's the industrial belt.
yes, sir.
And I don't, maybe arsenic, maybe a bit less, but there may be other contaminants
Yes, sir.
because they are discharging regularly their waste and everything.
Yes, sir. Yes, sir. That's
It
why,
is
sir.
going.
Yes, sir. So that's why, sir, if you take phosphate and nitrate also, is really another challenging area, sir.
Yes,
So
and
that is
especially
also,
maybe some heavy metals
yes, sir.
which is affecting us.
I am not talking about all these things. Lead, cadmium, that is also it is coming. Yes, sir.
It is coming,
Yes.
and I think when we'll discuss about the project,
Yes.
we can give some emphasis to Haldia also.
Yes, sir.
So
Yes.
it's an industrial belt.
Yes, yes. Because since it is one is the industrial belt, in that way we can highlight, or in that way we
Highlight.
can define. One is the industrial belt, another is a non-industrial, like this.
Right,
industrial,
right, right. Yes,
then effect would be, yes, that would be also.
because agriculture field, that is okay. Many people are saying that at the root level, huge arsenic is found.
Yes.
They are saying,
Yes.
and I think that whatever you are saying, phosphate or other metals, you know, it is quite possible that Haldia you may get those things,
Yes. Yes.
and the people don't know about it.
Yes. Yes.
You know,
That.
maybe in future it will take a bigger shape
Yeah. Yes. Sure.
in connection to groundwater contamination. Is it not?
Yes, sir. Yes, sir. Ultimately
So
leaching. Ultimately leaching, sir. Ultimately leaching to the
ultimate
ground.
leaching,
Yes.
ultimate leaching will take place, and it will ultimately, and it is becoming bigger also, because
Yes.
Haldia is becoming bigger because
You know,
many other
sir,
countries.
in your project, if we identify the belt, which area it is probable area, the leaching. So in that case, we can do the management action plan. Actually, that is also is a big project.
Actually, problem is that whenever we are trying to connect industry is not always sharing data,
Yes, sir.
and but we know that they are discharging many things
Yes,
huh,
yes, that is also.
in many way.
Yes,
So I think if we have a project,
yes,
DST project, then it is not that whether they are willing to share the knowledge or not. We will do it in our own way, is it not? They are. It's the government project, so naturally we have to allow.
yes,
We can collect the effluent and other things. So this is what is my proposition
yes, sir.
from HIT. Thank you very much for highlighting important aspects, really important aspects.
Yes,
And uh, we have to do something in this particular area, because without that, we will not exist at all.
yes,
Because
sir. Sir.
the
Quality
things,
issues.
whatever you have shown,
Yes, sir.
that whatever the people are affected and their hand is totally gone or leg. So we should do something for that. And within a very short time, I'll be just calling that meeting, maybe initially online,
Sure, sure.
and I'll talk to you when you will be free. We
Sure,
will
sir. No
connect that.
issues. No issues.
Huh?
Yes, okay, sir.
So
Anytime you are,
thank
sir, you are my teacher. So now my Haldia Institute Technology, they should be happy like you. You are a big
no,
teacher. We know everybody knows you, sir.
no,
So,
no, no.
Somnath
It's,
Ghosh now, sir, Jadavpur's key. He was there, sir.
no, no.
So now you are there means all colleagues, I must say, they should be happy like you. And
One thing, Pankaj, I wish to share, you may be happy. In our Jadavpur University, there is a current,
yes,
and if somebody is there in Jadavpur University, you can feel.
yes,
From outside, you may not be able to
yes,
feel
yes,
our
yes,
relationship, our
yes,
research, everything.
yes,
I
sir.
tell you, in the same thing is happening in Haldia, in
Oh,
HIT. Here is also a current.
okay, sir.
Nobody can understand from outside.
Okay,
But
sir.
when you will discuss it, then you will find it's a totally different private institute compared to any other institute in West Bengal and other places.
Nice,
So,
sir.
so it is a mini Jadavpur University.
We need the other more than
Yes,
good, sir.
and I am enjoying every moment in Haldia, every moment.
Yes, sir. Okay. So
Let
now,
us try to do it jointly.
sure, sir. Sure,
You
sir.
know, Jadavpur is always extending
Exactly.
hand to
And
everybody.
exactly. And
So
when you are there, so all of you are should also. We are. I personally, sir, when you call anytime, so I am. Yes, no, sir.
thank you very much. Thank you.
Yeah.
Thank you
Thank
very
you,
much.
sir. Thank you, sir.
So shall I remove, sir, madam?
Yeah, yeah. Why is our coordinator? Who is the coordinator?
Yes, sir.
Yes, sir.
Atrey, can you continue?
Yes. Yeah, sure, ma'am.
Akshay, do you want to
Yes,
close
sir.
or? Uh,
Yes, sir. The question and session is done. And, sir, you may leave at your own means account.
no.
No problem,
Now
sir.
we are free.
Okay.
Is it not?
Yes, sir. You are free, sir. Yes, sir.
Thank you,
And thank you,
Pankaj.
sir, for this wonderful session.
Thank you,
Thank
sir.
you, sir.
Thank you, ma'am. Thank you, all teachers.
Thank you.
Thank you, sir. Somnath, sir. Especially thanks once again, sir.
It's okay. Thank you.
Okay, thank you, sir.
Now, thank you all the participants for their presence on this session. Dear participants, please note that our next session will start tomorrow at 11 a.m. It will be a very interesting lecture on the topic of durable bituminous and concrete pavements by Dr. M. Amarnatha Reddy. Please join tomorrow's session 5 minutes before the scheduled time. With this, we've come to an end of 4th day of our 5-day online FTP program on recent trends in civil engineering. Thank you. See you again tomorrow.